Thank you for attending the 2022 Smart Port World Forum. I am your MC. My name is Shinji. Today we are in full compliance with the infection control measures of the government regarding COVID-19, and we are live online as well. And you can watch this event on the official YouTube channel of Yeosu Gwangyang Port Authority. We have an opening performance ready, and it is about AI. We combine AI and art performed by humans as well. We have Professor Jihae Park, a very renowned violinist, with us today. The artist was born in Germany, and she has spoken in the TED main stage and also is teaching at Yeonse University in Korea. So we have a world-renowned violinist to perform with you, and the two keywords of the performance will be AI and art. So I hope you are looking forward to it. We are also looking forward to your comments on our YouTube channel, and we will be selecting commentators randomly to distribute coffee coupons. So we ask for your active participation. Now, we are ready for the performance. Please greet Ms. Jihae Park with a big round of applause.
안녕하세요. 전 바이올리니스트.
Good morning. My name is Jihae Park, and I am a violinist. What did you think of this piece? Did you think it was Beethoven? I'm sure there were some videos played in the background. Last year, during the pandemic, I tried to work with AI, and we put in 10 of Beethoven's pieces in the AI program. And so it's a new interpretation, AI interpretation of Beethoven's Sonata 11. So it's an interpretation by the AI actually. And it's actually 20 minutes. So we try to summarize that into just a couple of minutes today for you. For today's World Forum on Smart Ports in 2022, I tried to think of rivers, oceans, and innovation. And so that is why I chose this innovative piece that has been interpreted by AI. Also, I will be performing on the topic of water, a drop of rain, forming to become a river, forming to become an ocean, and how the oceans have impacted the civilization. I prepared and wrote a new song, and I also developed and produced a video on it. And so the title is River to the Ocean. Please enjoy.
옹달샘에 한 방울이 떨어집니다. 강으로 점점 흘러가요. 한 방울의 물이 바다로 흘러들어가 기적을 이루는 것처럼 그 가운데는 그 꿈이 실현되는데 늘 찬란한 빛만 있는 거 아니고 낫만 있는 거 아닐 거 아니에요. 그 가운데는 그 여정 가운데는 이렇게 지극히 어두운 밤도 있을 거고 그리고 어두운 이런 암흑 같은 칠흑 같은 어둠도 헤쳐 나아가야 할 것입니다. 그래서 이렇게 월광 담아 보았습니다. 이제 여기를 토대로 저희는 희망찬 그 내일을 향해 배를 저어가자 희망의 나라로 향해 가는 의미에서요. 저의 마지막 곡은 바로 이 곡입니다. 이제 바다에 도착했어요. 마지막으로 희망의 나라로 출발합니다.
A world-renowned violinist, Miss Jiyeon Park. Please give her one more round of applause. In order to develop the roadmap of smart ports and also to implement the roadmap, we have invited all of the related experts here today. We are now ready to begin the 2022 Smart Port World Forum under the theme of exploring the ways toward smart ports. I hope that this forum will contribute to better understanding of smart ports and will become a catalyst in developing policies for supporting smart ports. So I will ask you to stay with us till the very end. Like I've mentioned earlier, we're also being aired online. The event is being shown by many online viewers today. I asked the online participants to actively write comments. We will be selecting commentators randomly to distribute coffee coupons later on. So I think there are a lot of people who are joining online. One comment is that, congratulations for the 2022 Smart Port World Forum. I really enjoyed the opening performance. Another comment that we see online, Yeosu Gwangyang Port Authority is one of the most advanced authorities in the port authorities in the world. Congratulate you on the 2022 Smart Port World Forum. And also another comment says that we are looking forward to the forum. I'm really looking forward to learning a lot on the most advanced technologies on smart port. So I will go and read the comments from time to time during the forum today. And also, those of you who are here can go online and write comments on the official channel, YouTube channel of Yeosu Gwangyang Hammam Port Authority. Also, another online comment, Shin Seohyun. I hope that solutions to building and operating smart ports will be found through today's forum. And we see a comment on the performance. So you have written this classic piece using AI. There is unlimited potential of AI application. So I ask for your continued interest on our online channel. We have participants joining online, joining offline, and we see many people are cheering the forum so that it can be successful today. We see a lot of comments saying that they really enjoyed the violin performance. And for the first time, we are holding this Smart Port World Forum. So it's the first Smart Port World Forum that is being held today. This is related to leveraging the fourth industrial revolution technologies to automate and strengthen the intelligence of ports so that we can connect the ground and ocean transportations to promote eco-friendly transportation and also, of course, economic efficiency. The smart port is, I think everyone knows its importance. If you don't, I think today will be a great opportunity for you to find out. We have 3 sessions ready. We also have a keynote speech ready as well. If you have any questions, we will have Q&A sessions in between. So I'm sure that you'll be able to fulfill all of your curiosity today. Ministry of Oceans and Fisheries have supported the industry in order for the port industry of Korea to become global. Of course, there is also the automation testbed that was held in the Yeosu Gwangyang ports. And I'm sure that all of your interest will be necessary for Korea to become a maritime port powerhouse. We have exhibition booths just outside the hall, so I urge you to take the time to go through those booths. There is a showcase of diverse technologies regarding automations, robots, all the technologies that are cutting edge that can be applied to ports. Now, I would like to introduce the Minister of Oceans and Fisheries and the special guests. Please give them a big round of applause. Today, you can see the AI robot who is guiding the special guests, like the theme today, Smart Port. The name of the robot is Chloe, so please welcome Chloe as well. So I mentioned that the booths outside are showcasing a diverse array of technologies. So please take your time to enjoy and experiment with the most advanced technologies regarding smart ports. Yes, Chloe. Please give Chloe a big round of applause as well. Good morning. Thank you for attending the 2022 Smart Port World Forum. We are in full compliance with the government's COVID infection control measures. And on the official YouTube channel of Yeosu Port Authority, this event is being aired. Of course, it's also a global international forum, so we are providing simultaneous interpretation in Korean and English. Korean is channel 1 and English is channel 2 on your receivers. I would like to go over the agenda of today. This event is hosted by the Minister of Oceans and Fisheries and the Yeosu Gwangyang Port Authority. The theme is exploring the ways toward smart ports. We have the opening ceremony and keynote speech in the morning, and we will have 3 sessions in the afternoon. Challenge to port automation, ever-developing intelligent ports, and moving toward full-fledged smart ports. So I hope that you will stay with us till the end to gain more insights. Now, we are ready to begin the 2022 Smart Port World Forum. I would like to first introduce the very special guests that are here with us today. If your name is called, please stand and look back. There is a camera, so please say hello to the camera in the back. First, we have Minister Seung-hwan Cho of Minister of Oceans and Fisheries.
And we have from the organizer, CEO Park Sung-hyun of Yeosu Gwangyang Port Authority. And we are also joined by Honorable Hwae Jae Kim, a member of the National Assembly covering Yeosu Gwangyang area. He's also from the Minju Party. And please give another round of a big applause to all the participants who are here despite busy schedules. I'd like to ask for your understanding that due to time constraints, I cannot introduce each and every one of you. As the theme of this conference elaborates on, why won't we take a look at this video, which will tell us where we should go in developing smart ports.
Changes. The future is right next to you. The smartest story. Smart Port World Forum 2022. Today's most important asset, time. Technology enriches our lives and transforms time. Artificial intelligence, Internet of Things, information and communications technology. All these technologies are moving for you. How to make things faster and safer? How can we be more accurate and efficient? Saving your time and addressing all the issues and tasks with the click of a mouse. Automated port. Innovation in the logistics process. The ever-evolving smart port system. Lead us to enjoy unprecedented convenience and simplicity. Smart Port World Forum 2022.
네, 여러분 다시 한번 큰 박수 부탁드립니다.
Please give another round of a big hand. The video clearly showed us why we should go for a smart port. As we expand our port into smart port, this will serve our national economy and the export industry, and this will further promote the convenience of our lives. And Korea, to become the leader in smart port, we should continue our efforts. And I'd like to ask for your full support and participation in this journey Then let us begin 2022 Smart Port World Forum, and I would like to invite Honorable Minister Cho Seung-wan of Oceans Fisheries for his opening remarks.
Good morning, everyone. My name is Seung-wan Cho. I am the Minister of Oceans and Fisheries of Korea. Today, I am very pleased to host the 2022 Smart Port World Forum. First of all, I would like to extend my gratitude to the CEO Sung-hyun Park of Yeosu Gwangyang Port Authority. I would also like to take this opportunity to thank Member of the National Assembly, Hye-jae Kim of Yeosu, for taking the time out of busy schedule to be here with us today. I would also like to extend my appreciation to all of the special guests and the speakers and panelists who have attended today's forum. Ladies and gentlemen, ports are the gateway for Korea to connect with the global community. It is also a key infrastructure of national economic development. 99.8% of trade cargo is processed at ports. Steel, petchem, shipbuilding, and the other related foundational industries are based in ports. And now, Korea has become an economic powerhouse that is based on a tight logistics network and advanced ports. Today, the keynote speaker is Mr. Mark Levinson. In his book, The Box, he mentioned that one of the unexpected results of the box is Korea overcoming poverty to become a global trade powerhouse. I would like to add some of my thoughts to this statement. Right after the Korean War in 1953, Korea was one of the most poorest countries in the world. But in 1967, by the Gwangyang port, Korea's largest petchem industrial complex was built in Yeosu. In 1974, Korea borrowed from the World Bank and Saudi Arabia to develop the North Port Container Terminal in Busan Port. In 1986, we opened the Gwangyang Port. In 1987, we started the first stage of the container terminal in Gwangyang Port. In 1997, we began construction of the new Busan Port, and in 2006, the first container terminal was opened in the new Busan Port. Now, Korea has become one of the 10 largest economies in the world. The government and also the business sector all headed toward the same goal and made great effort to achieve these results. Today, global ports are facing digital transformation. Major ports are introducing digital technology to promote automation and intelligence, which is enhancing operational efficiency. The ports are competing and working to provide new logistics services to its clients. Global companies are capturing this new opportunity in the smart port logistics segment and is making great effort to preoccupy the market and develop related technologies. Korea is also facing urgent need to develop the industrial foundation for port automation and smart ports. The Korea government has not yet introduced automation in all areas of ports, and the entry of Korean companies into this growing global market is not easy. The industrial foundation in Korea regarding port equipment manufacturing has weakened as well. Ladies and gentlemen, the Ministry of Oceans and Fisheries is working to deliver the dream of Korea becoming a logistics powerhouse and an economic powerhouse. We are making great effort to establish the top smart ports in Korea, and is supporting the related industries. We are boldly investing in R&D, and we are working to secure world-class technology by 2025. We will also ensure that the Gwangyang automation testbed will progress without any issues. Korea's ports are introducing the latest smart technology, and this will help Busan, Jinhae, Gwangyang, and Incheon ports to secure global competitiveness. We are also promoting international cooperation and supporting local companies to enter global markets. We will be working to invigorate investment and startups in this area, and also we will be ensuring that we are nurturing the right talent so that we can create the ecosystem for port equipment industry as well. We are working to also establish a platform so that companies and businesses in various segments can all work together to develop converged technologies. We are developing the industrial development plan for the smart port equipment, and we are making the greatest effort to become a leader in global smart port technology in 2030. Ladies and gentlemen, the theme of today is exploring the ways towards smart ports. I ask everyone to actively participate and gain insight regarding these topics. I would like to thank all of you for contributing to the foundation of policy development of Korea's smart ports. Thank you.
Thank you very much, Minister Cho Seung-hwan of Oceans and Fisheries, for your opening remarks. As he mentioned, ports are the backbone of the national economy. Therefore, we should strive to secure competitiveness of ports by building smart port, and he also promised the government full support. Now, I'd like to invite CEO Park Sung-hyun of Yeosu Gwangyang Port Authority, the organizer of this event, for his welcoming remarks. Distinguished guests, good morning. I'm Park Sung-hyun, the CEO of Yeosu Gwangyang Port Authority. It is a great honor to invite you to the first ever Smart Port World Forum. It feels like we welcomed autumn just yesterday, but the season of heavy snowfall has already passed. I'm deeply grateful to Minister Cho Seung-hwan of Oceans and Fisheries for his efforts to help develop the shipping industry despite the recent global economic crisis triggered by multiple complex issues after the pandemic. I also would like to express my sincere gratitude to Honorable Hee-jae Kim, the member of the National Assembly, as well as Dr. Mark Levinson, the author of the box, who is here for the keynote speech, and to all the speakers and all those from the shipping and port industry who came to celebrate this forum despite their busy schedules. Distinguished guests, Yeosu Gwangyang Port plays a pivotal role as the only logistics port in Korea that handles various types of cargoes such as containers, steel, oil, and automobiles. As the largest petrochemical and steel port with the largest export and import traffic volumes in Korea. In addition, the total project cost of 691.5 billion Korean won has been invested to build a world-class automated pier, and the Gwangyang Port Container Pier Phase 3-2 Automation Testbed Construction Project is underway. This is one of the tasks set by the national administration. Through this, Gwangyang Port will be reborn as a smart port where all processes are automated from container loading to transfer and transport. amid the fourth industrial revolution represented by artificial intelligence and big data. In 2027, the Korean smart port, starting from Gwangyang port, will set a new standard for smart ports using IT-based fourth industrial revolution technology, and will be presented to you at the container pier of Gwangyang port. I would like to build the most convenient and most advanced automated smart port in the world. That's my vision and goal. As automation technology is introduced across the board in all areas for the first time in Korea, this will serve as a roadmap for Korean smart ports. This year's edition of Smart Port World Forum aims at defining a Korean-style smart port model under the theme of exploring ways towards smart ports and sharing the experience and know-how of overseas leading ports with smart port experts around the world. In addition, we will closely collaborate with government agencies and experts in each area port to seamlessly carry out smart port projects and strive to build the world's best automated port and pier. Once again, I would like to express my sincere gratitude to the distinguished guests from home and abroad for their presence to celebrate the Smart Port World Forum, and I wish you and your family all the good health and happiness. Thank you. Thank you very much. Park Sung-yeon, the CEO of Yeosu Gwangyang Port Authority, as I listened to his welcoming remarks, I could see his full commitment to building a smart port. And I could see many people are fully dedicating themselves to have the best smart port in the world. Now, I'd like to invite our keynote speaker, who is the most influential journalist in the world and who is also the author of The Box. Dr. Mark Levinson is our keynote speaker. Please welcome him with a big hand.
The economist and the journalist Mark Levinson to the stage with a big round of applause. 네, 영어로 진행되는 만큼 통역 수신기를
Simultaneous interpretation will be provided. Korean is channel 1 and English is channel 2.
Hello and good morning to all of you. It is a great honor for me to be invited to be with you here today and to learn about this exciting project to develop smart ports in Korea. Today I want to talk a little bit about the history of container shipping, its current status, and then I want to give you a few ideas about where I think the future lies. Today, people don't think much about the history of container shipping because it's always been there for them, but container shipping has a history. And it started a very long time ago. Let's see if I can make this thing move here. There we go. So there's the start of container shipping. This is not a 20th century idea. The idea that it was cheaper and easier to put goods into a box and just move the box actually goes back to the 1700s. Many people tried to do it, and none of them were successful financially. It's not hard to imagine why. Take a look at this container here. You could put it on a ship, you could put it on a train, but what do you do with the container when it gets to the other end of the voyage, when it gets to the other end of the train ride? And it was clear that to develop containerization, you didn't just need a box, you needed a system, a new way of thinking about moving freight. There was a lot of demand for that. How many people here were in the port industry before 1960? I don't see a lot of hands, people who were in the port industry that long ago. It was a very inefficient industry. A lot of folks worked on the docks. Thousands and thousands of people worked on the docks. And they were moving individual items of cargo, like what you see here. A typical ship in those days, say a ship that sailed across the North Atlantic, might have 200,000 separate items on it. And each of those items had to be loaded onto the ship, taken off the ship at the other end. It was slow. A lot of things got lost and damaged. And as a result of this, trade was costly, and there was a lot less trade. It simply did not pay to ship many things, and that's really what the container changed. Sometimes people get romantic about the olden days, and I think it's important to remember that container shipping brought other kinds of advantages that we don't think about much today. The work that people did on the docks was often dangerous. It was difficult work. People think a lot about the dock workers and the ones who may have lost their jobs in the containerization process, and it's true that many people did. But a lot of those people went to work every day knowing that they could hurt themselves, knowing that bad things could happen to them because they were working directly with their hands and directly with, in this case, scrap metal. And as a result of that, many workers were injured. In the United States, in the United Kingdom, which is where I have data from, dock workers had the highest injury rates of all industrial workers. So it was a really good thing in some ways to get rid of that. And then the system of shipping was simply unreliable. Vessels could spend weeks and weeks in port being unloaded and reloaded. Here you see a picture of New York. You see that the piers stuck directly out into the sea. And a ship would pull up next to one of those piers, it would tie up, and it would sit there for days or weeks with all of those 200,000 pieces of cargo being removed, and then 200,000 pieces of other cargo being put on it so it could sail away. This was not an efficient system, and it required major changes. There was a lot of research being done on this in the 1950s. Nothing had led to an economically viable solution. And that changed only in 1956. You probably know the name of Malcolm McLean, who was a man in the United States who owned a trucking company. His concern, the reason that he was interested in containers, was that his trucks were getting stuck in traffic jams. He thought that maybe if he could put the trucks on a ship and take the ship along the coast, they would stay out of traffic. He wasn't interested in globalization. Nobody was interested in globalization. This was simply an improvement that would help his business. And I think we've seen in the history of containerization that there's been one improvement after another, each of them individually fairly small, that have made the system function better, have reduced costs for shippers, have made trade easier, and have totally changed the way that ports operate. Now, ports. The world's existing ports just weren't ready for containers. You know, many of the biggest ports were in the middle of giant cities. London, New York, San Francisco. Places where you could not bring in a lot of trucks, you couldn't take out a lot of trucks, you couldn't store the cargo. They were not suited for container shipping. And so there was a whole new generation of ports. This was new construction in new places often. But even so, these data are 3 years after the first international container voyage in 1966. And how big were the world's biggest ports? The biggest port in the world at that time was New York and New Jersey, and it handled 400,000 TEUs, approximately. The biggest port in the world today handles approximately 100 times that many TEUs in a single year. The top 10 list here included ports that moved as few as 82,000 TEUs. Today, a port that handles 82,000 TEUs is a very small port. So the scale of this business changed quite remarkably, starting really in the 1970s as shippers began to pump more cargo through. It's always important in thinking about the growth of containerization to remember that this is not something that's driven really by governments. It's driven by customers. It's driven by businesses that want to ship goods. They're the customers. They're the ones who decide what moves in international trade. Well, there we go. What happened as the ports learned to handle containers was that the productivity of port workers rose very rapidly. Suddenly, it was possible to move a lot of cargo at lower cost, or to move lower value cargo at a reasonable cost. Before containerization, it didn't really make sense to ship a pair of socks, a bottle of inexpensive wine. I went to the beach this past summer with my grandson, who had a plastic bucket made in China. It probably cost $1. And it's hard to imagine that it makes sense to send a plastic bucket worth $1 from China to the United States, but the cost of shipping has been so low that people have been able to do it profitably. And what occurred as the cost fell is that businesses discovered new ways to use the container, new ways to use shipping. This is where globalization came from. Nobody said, oh, let's globalize. Businesses saw that there was a different cost structure, and they could use that to set up their supply chains in a different way. They did not have to have everything in a single place. They could make components here, and they could make other components there. And for the first time in the 1980s, most world trade was what we call intermediate goods. Intermediate goods, things moving from one factory in one country to another factory in another country. The consumer doesn't know anything about this. The consumer doesn't see this, but that's most of what is in these boxes. And that was an entirely new phenomenon. That was a different sort of international trade than the world had ever known before. This led to the creation of these immense international supply chains. I put the starting date for these around 1987. You can see this in the trade data, that around that time there was a very sharp growth in the export of manufactured goods relative to the world's GDP. Around that time, there was very rapid growth in the export of intermediate products, the sorts of things that are moving from a factory in one country to a factory in another. And this is really what transformed the world economy. But it's also created some issues, and I'm going to talk about those in a minute. We saw for 2 decades, starting around 1987, that international trade grew twice as fast as the world economy. The world became very trade intensive. People expected that this was going to continue. This was going to be normal going forward. Well, it turned out not to be quite as normal as people thought. One thing that was very important in the growth of these supply chains, which people forget about now, is the shift of shipping from a spot market to a contract market. Since the 1980s, and especially since the 1990s, most goods that move internationally move under contracts between shippers and carriers. That goes for the maritime piece, that goes for the railroad connection or the truck connection at either end of the voyage. And this has really enabled a lot of investment in the industry, and it has ensured that services meet the needs of the shippers, the customers. Okay. So I sometimes have to explain to people, you all know this, but if you drive up to the dock with a container, nobody really wants to do business with you. The ship lines and the ports and the entire logistics system is built around these long-term relationships under contract to move large amounts of freight. And this is what has helped the system become so efficient. I'm using US data here because that's what I have, but I think you'd see much the same for other parts of the world. A key aspect of this development has been confidentiality. We had an experiment in the United States. We allowed contracts. The contracts were not confidential, and guess what? Very little freight moved under confidential contracts. Once confidentiality was allowed, then this sort of shipping really exploded, had extremely rapid growth. And this is what we came to know as globalization in the 1990s and in the early 2000s. Okay. And as a result, container shipping grew much more rapidly than the world economy as a whole. This went on for 20 years, and people thought it was normal. People assumed that this would continue. They thought it would continue, and they built bigger and bigger ships. Starting in 2006, with the arrival of Emma Maersk, owned by the Maersk Line in Denmark, ships that had been 8,000 or 9,000 TEUs were now 16,000 TEUs. There was much more cargo carried on a single vessel than ever before. It was assumed that this was going to further reduce costs, bring economies of scale to the industry, reduce greenhouse gas emissions per container. It would promote globalization. And it did the opposite. Trade became slower and less reliable as these giant vessels came on the scene. Why? Well, one reason was the ports were not ready for them. the ports were not equipped to handle vessels of this size. But another reason is that the ship lines and the shipbuilders assumed that the cargo on these vessels would just be taken care of. Somehow it would get into the port and somehow it would get out of the port. And they didn't devote much attention to the possibility that the cargo would just stack up at the port, that there would be more cargo than they could move in and out, that there would be logistical problems on the land side caused by this shift to giant vessels. These enormous investments in giant ships started to become widespread after the financial crisis of 2008, 2009. Talk about bad timing. This is timing as bad as you could imagine, because after the financial crisis, the growth in trade was much slower than before. Trade, after growing twice as fast as the world economy for 20 years, began to grow more slowly than the world economy. And all of this capacity on board ships was coming online even as the demand was very weak. We've just been through this period of high ship rates due to COVID, but people have forgotten about this history. People have forgotten that from 2010 to 2020, all of the ship lines were losing money, record amounts of money. Many ports were losing money. They didn't have the cargo they needed. There had been this expansion throughout the industry on the assumption that growth would continue to be extremely rapid, and growth wasn't there. These vessels were sailing around the world half empty in many cases, and of course that meant that the environmental benefits were not realized either, because while these large ships had lower emissions per container when they were full, they didn't have lower emissions per container when they were mostly empty. So the COVID-19 pandemic brought some relief to the ship lines and the ports. It brought them record profits, but that's really only a temporary situation, I think. We're moving back into an environment where there's a lot more competition, where the ship lines again have to compete for cargo, where the ports again have to compete for cargo, and there's overcapacity through the system. So it's a more challenging environment than the ship lines and the ports and the trucking companies and the railroads have had for the last couple of years. And I think it's going to push some more changes in the industry going forward. We're looking, now that the pandemic is past, at relatively slow growth again in international trade. It's not going to go away. I don't even think it's going to shrink, but we're not going to go back to the days when trade in manufactured goods grew twice as fast as the world economy. Why? One reason is that all of us are getting older, and our country's populations are getting older. That's true for Korea and Japan and China and Russia and Germany and England and the United States and Canada and about 50 other countries I haven't named. We now have several countries where the median age, that is half the population, is nearly 50 or older. People in that age group don't buy much stuff. We have our houses, we have our furniture, we have our clothes, and so the consumer demand is different and tends to be more towards services rather than goods. We're also seeing that a lot of goods that we used to trade internationally are becoming services. There used to be a big business, for example, in sending consumer electronics equipment from Japan and Korea to the United States. Well, how many people have phonographs now? Okay. This kind of equipment doesn't exist much. Music is a service. We purchase it as a service. We don't purchase goods for these purposes. We can use one device, and we can use it to listen to music and watch television and play games and many other things. So these products that used to be carried in container ships, in many cases, are just going away. Cloud computing is another example. It's great in a lot of ways, but it means that individual companies don't need to invest as much in their own computing systems because computers can be shared. So the net result is fewer units of computer that need to be moved in container ships. We're seeing technology eliminate other categories of product that have been very important in shipping. We're in the midst of a transition now to electric vehicles. Well, auto parts, engines, transmissions, catalytic converters are one of the most important commodities in international trade. Electric vehicles don't have any of those parts. We're having this cargo disappear. Not immediately, but as electric vehicles become a bigger and bigger share of the market, there's going to be less demand for this. Light bulbs, well, it's a commodity you don't even think of, but light bulbs are in many uses being replaced by LEDs. They'll last a really long time. You don't need to import light bulbs. In the building where I live, we're buying new exercise machines. The old exercise machines had lots of weights and cables, all of which had to be shipped internationally. The new exercise machines don't have any of those. These are the sorts of technological transformations that are limiting the amount of cargo that's moving in international trade. And so it's going to exert additional pressure on the carriers, on the ports, on the truck lines. It's going to make some of their cargo disappear. So I think we have an interesting situation for the ports going forward. I wanted to raise a few questions for people to think about and perhaps to discuss here. One is alliances. The result of having so many large ships with not enough cargo is that the ocean carriers formed alliances to work together to keep their ships full. Today, competition authorities in North America and in Europe are evaluating whether these alliances should be permitted to continue. There is an assertion that these alliances might be anti-competitive. This is being investigated. If the alliances are restricted in some way, that means that there may be more individual carriers trying to find a place in the ports, because rather than dealing with 3 or 4 carriers as a single alliance, the ports will have to deal with the different carriers individually. This may create opportunities for some ports. It may weaken the carriers' bargaining power against the ports, but it's a very different situation than you have today when world trade is dominated by just 3 or 4 alliances. You could easily have a dozen companies that are actively involved in world trade as ocean carriers. A second thing that I think we have to think about is slow steaming. We've had slow steaming now for a decade. This was one of the results of the mega ships. How do you make these mega ships profitable when they're losing a lot of money? Well, one way you make them profitable is slow them down so they don't burn as much fuel. As the world shifts to sustainable fuels, and this shift is underway, there will be more pressure for slow steaming as a means of reducing emissions, because these alternative fuels are likely to be expensive. And so the carriers will face pressure to reduce costs, and they do that by having their vessels move even more slowly. How is that going to affect decisions about where to manufacture different things? This goes hand in hand with higher interest rates and changes in other sorts of costs. Will manufacturers move production nearer to the markets that they serve? Will this affect demand for ocean transportation? I don't know the answer to this question, but it's worth thinking about because slow steaming and higher interest rates, I think, are going to be with us for a good while to come. We're seeing now that many ship lines are moving back to smaller vessels. They built vessels that could carry 20 or 25,000 TEUs, and in many cases they decided that this was not a good idea. Now we're seeing many carriers ordering vessels that are 14 or 15,000 TEUs. Also, we're seeing that the average trip on a container ship is shorter. This is in part due to changes in the location of manufacturing as well as the rapid growth of markets in Asia. Does it make sense to use a 24,000 TEU vessel on a relatively short voyage? Most people think not. So the current trend is towards smaller vessels. This is likely to have some impact on the ports. There are many ports that cannot handle 24,000 TEU ships. Perhaps they can handle smaller ships. The carriers will have greater flexibility to move ships between routes. If they're not happy with their business on one route, they can simply abandon this port and move to a different port, which is very difficult with the 25,000, 24,000 TEU ships. So we're seeing major changes in the fleet that are going to affect the ports. And then, of course, there's concerns about risk management. I'm sure all of you who are involved with the ports are hearing about resilience, redundancy. Nobody wants to put all of their business through a single port. People want choices. People want alternatives. People want information that helps them manage their risks. I think this is where the discussion about smart ports comes in, because it's not simply a matter of speed, it's a matter of alternatives. Okay? If you go to the airport today and you're taking an international flight with a connection and your flight is late, you can get information right away about changing your connection so that you'll get to your destination. That doesn't happen with shipping containers very easily. Your container's taking the first part of its voyage to a different port. Once it gets there, somebody will figure out how to move it to its final destination. And the customer can't get any information about when that container is going to arrive or what route it's going to take. There's a great opportunity here for smart ports. And lastly, the sustainability concerns. I think we're seeing particularly from ship lines that serve consumer goods ship lines that serve consumer goods companies, consumer-facing companies, demand for cleaner, more sustainable operations, and they will favor ports that operate more sustainably. So I think there are a lot of changes underway in the industry. How will this affect the logistics industry? I think that this warning here is very useful to us. It's easy to make predictions. In 1976, the Financial Times, that respected newspaper, said that the revolutionary impact of containerization had worked itself out. This was before we had the rise of these long supply chains in the 1980s. This was before international trade grew twice as fast as the world economy. So the revolutionary impact of containerization hadn't worked itself out. It still has not. And I expect we're going to see a lot of unpredictable changes over the next few years. I think flexibility is going to be the key to the future in this very fascinating industry. Thank you all very much. I'd be delighted to answer your questions.
네, 고맙습니다. Thank you very much. And we would now love to accept some questions from the floor. 네, 저희 그럼 기조연설 함께.
Thank you very much, and we will continue with some Q&A session. If you have a question, please raise your hand and we will hand over the microphone. And when you ask a question, please introduce yourself, your name and your association first, and then you can ask a question. If you have a question, please raise your hand. So if you have a question, then we will hand over the microphone, or you may stand up. The history, the present, and the future of containers. So we have a question on the first row. The gentleman on the first row, please introduce yourself. My name is Park Sang-ho. I am from Yeosu, Regional Office of Oceans and Fisheries. Thank you very much for your presentation. It was very insightful. As for container shipping, so you introduced the concept of a transit at an international airport. And as for international airplane, that is a standard. So the connection flight or data sharing can be done smoothly. So that's available. You can make a international transit at the international airport. But as for a smart port, there is no standard working throughout the globe. Each country has its own standard. So the connection might not be that easy for smart ports. So I'd like to know your take on the sharing of the standard as well as the collaboration among nations in building smart ports.
Thank you for your question. It's actually not right that each country has its own standard. In the United States, we don't have any standard. There are other countries that have several standards. There are many entities that would like to have a standard, but it's very hard to reach an agreement on a standard that meets everyone's needs. This is actually very similar to the situation that existed in the first years of the container, when different carriers used different sized containers and different ways of lifting the container, and there had to be an agreement on the standard size container. So I think we're in the early stages of trying to come up with some standards. My guess is that the standards will be very basic, because there are a lot of people involved in supply chains who do not want to share information, or they want to share as much information as is profitable for them and no more information than that. So there are some great challenges here in coming up with standards. But I think that there are many shippers for whom the information that smart ports could deliver would be very valuable. And the question is, how can there be a system set up that will serve their needs, and the people who aren't interested, they don't have to be involved. Okay, if they're shippers who don't want the information, who can't use the information, who don't see value in the information, then they won't pay for it and they won't have it. But I think that there are shippers who very much value this precise information, and they have to be a part of the discussion. In general, I think, as I said at the beginning, we have to remember that this business revolves around the shippers, the customers who are shipping goods, and not around the ports and not around the carriers. And we have to keep the focus on what will benefit the shippers and what they're willing to pay for. Thank you.
네, 고맙습니다. 시간 관계상.
So due to time issues, we will end the Q&A session here. Please give a big round of applause to the keynote speaker.
with us. 네, 앞으로
So The keynote speak was about the future direction of ports, and thank you for that very insightful presentation. So this will conclude the morning session. The afternoon session will happen after lunch. We will be giving out 6 copies of the book written by the keynote speaker today. And so please ask for your active participation during those events. We will have a group photo session, so please come up to the stage. Many ports are working to introduce digital technology to enhance the efficiency of cargo processing and offer diverse services to its clients. Global ports are making effort to increase their competitiveness by becoming smart ports. The recent disruption in supply chains and global marine transport is something that the ports are trying to overcome in the future, and we ask for you to participate in this forum so that we can all gain insights. So 2 rows, please, if you can form 2 rows. So please wear your mask. So please take off your masks. Big smile. So we have lunch prepared. Lunch will be delivered to your seats. We also have the booth right next to this hall. So please take time to visit the booth and experience the cutting edge technology in smart ports.
다시 한번 안내 말씀.
May I have your attention, please? We will soon start the first afternoon session of 2022 Smart Port World Forum. I'd like to ask you to take your seats so that we can begin. I'd like to ask you to come forward and take the seats on the first and the second rows. Simultaneous interpretation will be provided throughout this forum. The Korean is channel 1 and English is channel 2. And you can pick up the simultaneous interpretation device at the gate. Now, please make sure to return. You can leave the interpretation device on the table after use. We are holding various events, and those who are joining us online, if you post your comment on a real-time basis, and we can choose some people, and we will distribute a coffee coupon. And those who are here in person after the first session is over, and then after the second session, we will choose 2 people each to receive the box signed by the author. I'd like to ask for your active participation. Thank you.
네, 이제 저희 시작을
Then let us begin.
모두 착석해 주시기 바랍니다.
Please take your seat.
수학자 항만 국제 포럼
2022 Smart Port World Forum first session will begin. The first session is under the theme of Challenge to Port Automation. Let me invite our first speaker, Mr. Holger Schwett, who is the CEO of Akunet Port Consulting GmbH. Please welcome him with a big hand.
Yes, it works. So welcome after the lunch again. I hope you had a good lunch here. My was wonderful. Before I start, I would like to thank the organizers of this conference, the Ministry of Fishing and Oceans and the YJPA, for inviting me here. This is, let's say, some 2 months ago when I've been last time here in Korea, and they asked me whether it would be possible to come here, and it was, of course, it's a big honor for me to be here. So I will talk about securing smart operation on automated terminals from the first idea until going live and the whole time afterwards. Then this is the main part of a terminal when it really works. So, very short introduction. My name is Holger Schütt. I'm mathematician and made my PhD in automation. When I finished that, I went to HHLA, the terminal operator in Hamburg, which started the second fully automated terminal in the world, the Altenwerder terminal, and my task was like the title of my presentation, to secure the start smooth of this terminal. About our company, very short, it's the Aquinet Group, some 20 companies out of the IT, and we are doing, yes, let's say nearly everything around IT. If you need a data center, come to us. We do build data centers, we run data centers, we help you with your SAP and Microsoft installations. We also do individual solutions, and mainly we do business consultancy, and not only for the ports, but for, yes, all branches, for health and industry, manufacturers, digital government, a lot. But our part, what I will talk about today, is the maritime logistics, and it's on the upper left, the logistics. Just, oops, this was the wrong one. With some 1,000 people, we have a turnover of some 150 million euros a year. This was 2021. I think this year will be again nearly that. For the ports and terminals, we concentrate on 3 parts. We are not the civil engineers. We concentrate on everything around IT and processes. So on the left-hand side, TOS migration, TOS implementation, terminal automation, these are the services that we deliver. We don't deliver a TOS itself. On the right-hand side, you see our ChessCon simulation emulation system. We will see some pictures from that later on. And in the middle, you see the whole portfolio of consultancy around IT and processes. We are doing this all over the world in all 5 continents for the last 30 years already. So if we talk about automation of container terminals, there is a very good paper about planning automated terminals. Some 25 independent international experts from all over the world sit together to write this book, let's say, to write this study. I had the honor to be one of them. It looks not only at the IT, it looks at technical, economical, ecological, safety, and of course efficiency aspects. And very interesting, at the end, there is an overview about some 80 terminals which are semi or fully automated already. And also here, I found this preparation for this presentation today, that also YJPA is planning the full automation. And I took it out from the ESG Management Report 2021, where you see this is the main topic while we are here, the automation test field that we heard this morning already from the minister as well as from the CEO of YJPA. If you look at the drivers and expectations of automation, I don't want to go into depth here. I think most of you know it. There must be benefits, otherwise you won't do it. But I want mainly to go to one topic, and this is the complexity. In a manual terminal, if you think about the transportation of a container from A to B, there are people doing this, they are doing the decision. This is local decision on the single equipment. And in an automated terminal, you don't have this local intelligence. You have to put all the intelligence into one big IT system, control system. And also the processes are becoming more and more complex, not the standard processes, but all exception handling. Because in exception handling, you have nobody who can jump to this place and do something. Most parts are automated. So the IT systems have to be very complex, and therefore we have to look how to secure these operation. And simulation technology, emulation technology, visualization technology, these are parts that may help you a lot with this. from the first idea until operating these terminals. So visualize your ideas. If you have a picture in your mind, how this terminal will work, put it into a 3D model, show it to your shareholders, show it to the investors, to get the allowance to make a real world out of your idea. This is what Eurogate and Hapag-Lloyd did with the Damietta terminal in Egypt. And you see the picture from this 3D model, from this, in their press release when they announced they will build it. After having this idea, you have to go into details. What is the best layout for your terminal? Is it perpendicular layout? Is it a parallel layout? Are you using end-loaded blocks, or like in this picture, also some cantilever blocks for late arrivals of trucks when the containers come while the vessel is already loading? This has been a project also here from Korea, from Busan. We had a lot of analysis and a lot of models compared together with our local partner TSB. They were here, the local communication with the Port Authority, and we did in the background the simulations and the analysis. But also others are doing this. So this is a project from Adani in India. It's not fully automated, but they were thinking about the traffic on this terminal. You see, it's a quite long terminal, and a lot of trucks have to go there. Might be a bottleneck on the right lower side of this terminal, because all trucks have to go there, all external trucks. And they asked for looking at the traffic, how to handle it, perhaps using traffic lights in the terminal. This is already done in some of the terminals. It's also about the length of the blocks, the width of the blocks, the number of cranes you use, etc., etc. This is, I think, some stage that YJPA is now thinking about. And then, with the same models, you may go the next step. If you decided for a specific container terminal layout, then you have to build your control system. You have to configure it. And to make a smooth operation available, you can connect this terminal operating system, the TOS, to the virtual terminal, to the simulation model, instead of the real terminal. And then you have a test bed for your TOS. This is done by some terminals for changing the TOS, and also our partner here, Total SoftBank, one of our partners in Korea, Total SoftBank, they are using it in-house to secure the operation and the functionality, the efficiency of their terminal operating system. Why to do this? You always have to have a reason to do things. So if you do it without emulation technology, you think about your first terminal, demand analysis, system design. This is more from the IT side. It's one of two, I think, technical slides within this presentation. Then the TOS development configuration has to be done, and you test it against the real world, if the first equipment is arriving, if the pavement is done on the terminal, and so on. And after you tested everything, you may go live. If you use a virtual terminal instead of it, you can start earlier with the testing. You can test your TOS in a total other way, and you find a lot of problems before the first equipment is arriving. And when it arrives, when the terminal is ready to start, and you can test with the real world, the tests will be shorter, because it's only the testing of the equipment and the communication with the equipment, etc. It's not the functionality of the TOS itself. So you save time. You can go live earlier. And the lowest box on the right-hand side, continue to use. You can use it all over the time your terminal is running and makes money. So APMT, they use this technology in their headquarters to test new strategies in the real TOS before they go live on their terminals with these strategies. This is a terminal from Saudi Arabia. In former times there have been 3 terminals. Now they are under one control, and they thought about what are the strategies for this transshipment containers. 50% of them, of the containers are transshipments over there. If a container is discharged on the upper right and has to be loaded on the lower left, how to bring the container, when to do the transports, etc. These are all strategies that you may test, not in real life, but with this virtual environment. And last but not least, you hear a lot perhaps about the digital twins. This can also be done. What we saw before is something that you do in a laboratory. You run a test installation of your TOS against a virtual terminal. But now you connect the virtual terminal to your real world and you build a model of your terminal. You get it, you already have it. And the definition I like most, this is from John Vickers and Michael Greaves already in the beginning of this century. The digital twin consists of 3 parts: the real terminal, the virtual model, and the connection between both, so that the virtual terminal is all the time in the same state as the real world. And then there are some benefits you get from this. If you see here the digital twin, the real operation, this is the green one on the top. You have information about everything what is happening now and what happened in the past. The digital twin may have a simulation component inside so that you may look into the future. Will my vessel be finished on time with all the planning that I did in my real TOS at this moment? And the information is there. You don't have to set up scenarios. The scenario is the real life scenario at this moment. And you start a simulation with all the information out of this digital twin into the future. And also you may do it the other way around. What happened yesterday? Maybe there has been an accident. You can roll back. You can replay what happens yesterday with exactly the information of your terminal. So let's say it this way, man is thinking in pictures, not in bits and bytes or tables. So if you want the people to understand what is happening, present them pictures. And this is how this may look like, a 3D model with a real life operation. And you see the equipment is running, the whole terminal is running. This is similar to the terminal that APMT is using. And you see now the cranes, they have different colors. Not in the real world, but here you see this one is working, this one is waiting for the equipment, this one is waiting for a job. And you have much more than just looking out of the window. Here it looks like you fly over the terminal, but you can do much more by filtering your equipment, by filtering your containers. You can click on an equipment and you see what is this doing, what is his productivity just at this moment. Waiting for the next slide. So this first looks really nice. Maybe in the entrance hall you can show it, but this is not the real benefit of it. The real benefit really is marking or sending alerts if something is not happening as you expected, putting different colors on the equipment due to their productivity, filtering the containers according to their states, to their attributes. So we see it here with the filtering. These are the transshipment containers in the front, export in the back of the terminal, and so on. This is something you won't see if you look out of your window, if you fly over your terminal. But in the digital world, it's possible. And here you see the functionality of the digital twin. It's from a real project. You start with data collection. You have the analysis of the data. You visualize it. This was what we saw before. And then you can, as mentioned, start simulations into the future. What happens within the next 8 hours? Will the vessel be ready? Will there be bottlenecks before they occur in the real world? You can do also this shift replay, looking back, and you can use the simulation results for optimizations, AI-based optimizations, and of course you may have some small control functions. As mentioned, this is really a project that we are working together with the Eurogate group in Germany. And if we look at all this data, I think in the morning we heard something, there was one question from over there. What about standardization? It would be easy to know what where the container goes next if I have something like with the airlines, they have standardized interfaces. There's one initiative, the TIC 4.0. It's coming from the industry. Terminal operators, equipment suppliers, TOS suppliers, they all work together to define interfaces between equipment and IT systems and subsystems. Main thing is to get a common language first. So if you ask here in the auditorium, I have not the time to do it, but if I would ask you, what is the move under a container crane? I would expect 5 to 6 different answers. So first you have to say, okay, what do you mean if you talk about a move under a key crane? Then you have to develop communication protocols and frameworks, facilitate the interoperability, I don't like this word, of different information subsystems of a cargo handling facility. And why to do it? I think it's clear. If you, I talked about the CTA terminal in Hamburg, fully automated with the AGVs. CTA is not able to use an AGV from another supplier because the control system and the AGV, they are fixed together. There is a special protocol to run these AGVs and no other supplier is able to do this. But the first terminal which went live with fully automation was ECT in Rotterdam. There was no fleet control system, so they developed that by themselves, and now they can buy from VDL, from ZPMC, from Gottwald Konecranes. They can buy wherever they want. So this is the main thing of standards, and if you look, there are a lot of companies, organizations within this, and some of them, Konecranes, Kalmar, they already stated in the future, if you buy a crane, if you buy straddle carrier, an AGV, you will get the TIC 4.0 interface. If you want to have another interface, you have to pay for it extra. So standardization is very important, is one point. Automation will come because there are a lot of benefits. Automation is more complex. So to secure the operation, use what I showed, visualization, simulation, emulation. And if you got these things, then you can use it as a digital twin parallel to the real life. I'm looking forward to your questions in the Q&A session afterwards. Thank you.
네, 고맙습니다.
Thank you very much for your insightful presentation. Then during the panel discussion, we will address questions from the floor.
해주실 연사분은요.
The next presenter will be joining online.
사이버 로지텍 항만 솔루션
It is Mr. Chad Payne, who is leading the port solution operations of Cyber Logitech.
특히 완전 자동화
He will be talking about the system of full automation at ports.
Yes, sir. Can you hear us? Director
Chad Payne, are you here with us?
Yes, I can. Hi, hello, everyone.
Yes,
Thank you very much for the opportunity to speak with everybody here.
Yes, thank you very much for joining us today, despite of the time schedule and now, despite of the time difference. And now, as soon as now we have you seen on the screen, and with that, I'm going to leave it up to you, please.
All right, I'm going to share my screen, and we'll go from there, everyone. Thank you very much. Okay, so okay, all right. Let me pick this up. All right, this looks okay. All right, so hi everyone. It is an honor and a pleasure to be able to speak with this audience. I really appreciate the time here. So my name is Chad Payne. I work with Cyber Logitech. I'm based in Los Angeles, Long Beach at Cyber Logitech America, our office over here. And I have 20 plus years of experience in TOS implementation. Worked with multiple TOS vendors. As well as did 5 or 6 years over in Rotterdam, starting with ECT back in the mid-2000s, and then took Euromax live. I've worked also with some semi-automation terminals and getting involved with some of the Cyber Logitech activities that are going on, which I'm excited to talk about. But on a broader level, what are the different components that go into the decision-making for automated terminals? And some of the different considerations that you need to make. So, all right. Just to kind of give you guys our Cyber Logitech Opus terminal reference sites. Okay, so we have PNC and Jibalale 3 and 4, as well as the HDIT terminal in Incheon, Korea. Varying different types of equipment, varying years. TTI Spain, TTI Spain was done probably our oldest automated terminal that we've been able to do. The first ones are semi-automated with manned, horizontal transfer to the key crane, and we are now working with Beibu and GTT to move into the fully automated terminals with the TOS support of that. Okay, so we're going to talk a little bit about kind of our case study about what we've done at Beibu today, and then look forward to any further discussions we have. This is kind of our layout of our automation from Cyber Logitech. The complexities of automated terminals. Some of these, were mentioned and done, and a very interesting and well done job in describing some of the different activities prior to me here on some of this stuff. But certainly, as a TOS vendor, we need to look at, what type of equipment, what type of automation. You have side loading and end loading. Type ASCs, you're moving into the RTG cantilevers. So I may refer to all of the automated cranes as ASCs, but it's just kind of what I'm used to. But there's certainly different terminology for all this different equipment that people have. The interface and integration with the ECS and the FMS is a super important decision for any terminal to make. Who makes those optimization decisions? Who makes those dispatch decisions? Who makes the right decisions to fully maximize your operations? Certain terminals, the TOS does it. Certain terminals, there's third-party software that kind of comes on top and helps optimize decision making. And other terminals, the FMS kind of the equipment providers that are directly, connected and managing, the automated equipment, sometimes they will make the optimization decisions. So there's kind of pros and cons to each one. But, let's remember, in that decision making, the TOS generally has the most information in terms of what the work instructions are, what the job orders are, which containers need to go where and when, decision making on flipping out the containers, switching them to a more optimal one for like-to-like loading, let's say. A lot of decision making is made by the ECS and the TOS. So I think it's very important to figure out kind of the roles and responsibilities between the TOS and the ECS, whether that's within the TOS or external, and FMS. Okay, and the interfacing with the positioning systems, the transponders, keeping track of all the equipment, the GPS, and understanding where they are, which is generally managed by the FMS, but the TOS generally follows it. Emulation and simulation test, I'll get into a little bit what we did with Beibu, but certainly those are critical things. Simulation generally happens, at the beginning of the terminal, a design where you're trying to figure out your right equipment, your right layout, your right configuration, the right amount of equipment, which type of equipment. So a lot of work is done in simulation, but as you move, and that will continue on through, the decision making for finalizing the terminal design, the project implementation, and post-project implementation, because you can still run a lot of scenarios, get some data out of it. But the emulation really validates, the work instructions, the messaging between the two, or the multiple third-party vendors. So that is a key piece that needs to be taken into consideration, for any terminal as they progress forward. We have at CyberLogitech a lot of test and automated test tools. I think this is probably pretty common for all TOSes. You have a lot of changes, a lot of code releases from multiple vendors. You need to have an efficient way of being able to do your testing, and there needs to be significant investment and time spent on testing and making sure that there's no regression and you can move forward rather than introducing any new errors. Which brings us to the change management, of course. It's very complex with all the different vendors, lot of different software and code going on there. So you need to make sure you're maintaining the code releases and everybody's in sync, and the proper testing and coordination and documentation is done before any releases. As we get into the advanced features to support higher production, as we get into wanting to maximize the KPIs, certainly focuses on the job scheduling, the job control, managing the exceptions, what happens both on the TOS and the equipment side, auto rehandling, auto housekeeping, prefetching. How do you comb your ASC or RPG cantilever stacks to make sure that you are getting the containers in the best position for the job time to be met, depending on whether it's a gate delivery or a vessel delivery or what it is. And also there's, some shifting between, the water side, the land side, and of the ASCs, so that's a little bit more optimal as the work instructions done later. So that also needs to be taken into consideration and make sure that we're making optimal moves and doing the best to set up for success to maintain high productivities. Of course, the way that we set up our either manned or automated equipment, AGVs, shuttle carriers, there's some automated shuttle carriers, there's some manned shuttle carrier terminals I've worked with, your yard trucks, manned yard trucks, how you're pooling those, what working, are you assigning them all to vessel, are you going to assign them all to moving them from ASC to ASC to kind of do some shuffling, what is your strategy for that? I don't have all the answers, but here, I'm not going to go through all that, but I do know that these are the key elements that you need to consider for an automated terminal that you're going to do from design through the project phase and through the go live. Okay, so here's a nice picture of Beibu. It's the first U-shaped terminal layout. It's U-shaped for the external truck. So these are side-loading RTG cantilevers. Okay, so we have IGVs here with magnetic positioning, a side loading with dual cantilever RMGs. One side's the external truck, the other side for the AGV, or if we call them IGVs, they're kind of similar. And then this U-shaped layout for the external truck that goes down and comes up. Of course, we have the automation on the gate side. This is with Camco, with the gate appointment system, which creates transport order, so the weighbridge, typical, the gate processes that are automated that goes through to get the trucker in the yard. So at Beibu, which is pretty common, double trolley SDS crane, remote operation, and then there's a parallel buffer in the apron. What is interesting, at least in my experience, is I've worked in Europe, Africa, South America, and the U.S. The remote operation is becoming, I think it's pretty common in Korea, and in Asia, and probably seeing a lot more in Europe. But in a lot of other countries and regions, I think that this is becoming more popular, and I think people are going to start adopting it. And I think the standard is going to be remote operation versus man. Okay, so just a little bit of details here about, kind of this case study about Beibu. We've been operational since June of this year. So we're running the TOS, and we do, Cyberlogitech does have products to do, called Digital Twin, to do the simulation and the emulation. We have an IoT platform and a dashboard, which I'll go into in a little bit more detail here in a minute. We integrated tabs, which is kind of our own product for a billing and payment system. We're doing the scheduling and dispatch of the AGVs, and we're interfacing, with the GOS, which is Camco, ECS, and FMS, which is third party. And then there's a local system interface. So certainly a lot of third-party vendors coming in here. And a lot of integration and messaging going back and forth. Just kind of roles and responsibilities. The TOS handles AGV pooling, how you want to allocate it with work instructions, job scheduling, picking the right AGV to dispatch. The ECS is kind of making some more optimized moves, and you're kind of interfacing with that. And then the FMS typically manages the equipment movements, making sure there's no collisions or deadlocks, and giving it the optimal routing and just the control. But we do collect a lot of this information from the FMS over to our IoT platform. Again, clarifying the roles and responsibilities of where all this lies, which vendor, is responsible for which. Is a lot of, decision making that needs to be made in terms of the terminal and who they choose. So interfacing with the AGV, ECS, FMS. So what the TOS can do, is make decisions on which AGV to dispatch to, the optimal job order. And also, here's an example of, okay, we've received a message from the FMS that the battery status is low. So we give the AGV, a dispatch order to go to the recharging station, drop off the battery, pick one up. I guess I used to do the fuel, but I guess everything's now is the battery side, which is interesting. And so here would just be kind of an example of how the TOS also helps manage the AGVs to make sure that they're ready to go for the job dispatching. Okay, I won't touch too much on this because I really want to talk a little bit more in terms of detail here. But of course, we have EDI, we have our TOS, we have connections to the PDAs and the VMTs. But what is interesting is collecting the data into the IoT platform and creating a data mart. Okay, so What we use at CyberLogitech is typical stream-based to collect all signals from unmanned equipment, status, direction, speed, breakdown, etc. And we can create dashboards to be able to feed real-time operational data to the terminal operations as well as the management. Okay, so let me give you a little example of what that would look like. There's KPI monitoring, how you doing on your vessel cranes, what's your productivity, your asset monitoring, this is what this tab is selected. So here's your transfer cranes, which would be kind of like your ASVs or RTGVs, or RTGs, excuse me, your key cranes. You know, what's the driving distance? What's the, you know, what the productivity is? Is it below or above expected productivity? So we can provide this data so we can actively monitor it and see if there's any decision making or any alarms or critical issues that must be, you know, dealt with in terms of operations to keep things going. So key cranes, yard trucks, we go into a lot more detail here. You know, it's important to manage, you know, your driving distance. A lot of times, you know, the amount of fuel, and this can help you make more intelligent decisions and bring it back into the design, the configuration of the toss. Maybe you want to kind of rerun a simulation a little bit differently. Maybe you want your AGVs pooled. You want to minimize some of the driving distance or whatnot. So it kind of gives you a chance to kind of make adjustments real time or bring that data back into the simulation and see if any adjustments need to be made to maximize what your KPIs are. KPIs are always related to vessel productivity, although that's kind of the biggest one. But driving distance, fuel, you know, the amount of equipment that is used, those are also important KPIs that terminals need to manage. Okay, emulation test is what we do, and you know, in terms of working with a third party or working with our own products, you know, and before we get into the live equipment testing, but the emulation is super important, right? Because lab testing is really validating the messaging and what's going to happen in real time. And the workflow sequence configuration and validation can be quite complex. I mean, there's going to be thousands of messages coming through on a frequent basis, and everything needs to come through in the right sequence, the right format, and the right order. I mean, this takes time, right? I mean, you start simulation very, very early. You start emulation as early as you can once you get your vendors, you know, sorted. But you know, that needs to be a continuous process of validating things in your emulation and making sure, you know, any code releases, changes, upgrades, you know, also give us the same results, because some things need to make sure that there's no regression and everything can move forward. Okay. You know, there can be exception cases in automated terminals. There's a lot of exception cases in manual terminals. You get deadlock, AGV disappears, you know, you need to, it's over speed or over height, and you need to manage those exceptions, okay? One of the reasons why fully automated terminals not record high productivity is that, yes, the integration between the systems, especially at the beginning of the go live in the project, can be you know, take some time to overcome the issues, especially after you actually go live and actually see it actually happen, and you need to make your tweaks moving forward. But one of the advantages of, you know, being an automated terminal, based upon my understanding, is that, you know, once you get things kind of up and running and some of the, you know, stabilized, you can be predictable, you can be reliable, and liners like that. They know when their vessel arrives, and they know when it's going to depart, and they know you're going to hit your berth window. You might not hit some of the peaks of automated or manual terminals, but you're going to keep consistent and the same hour after hour, day after day, as you see in automated terminals. I think that is very important, you know, for the relationship with, you know, the customers and attracting people to bring, you know, containers to your terminal. Okay, simulation, very, very important. A lot of different vendors. We also do it, right? You set up all your planning data. You look at your container mix that you're expecting, exports, imports, reefers, OGs, hazardous containers. What's my container mix? What's my expected volumes and yard capacity? So you set up kind of a more of a difficult scenario, right? Where you want to say like, hey, what's the cost and the third and the other vendors going to do in these scenarios, and you want to kind of run this early and often to see, and you make adjustments to each of the vendors to improve things. But you definitely want to put up a scenario that's really makes sense for that terminal, that's going to be valid, that's going to be realized once you go live. And you can make adjustments, right? You might change your yard plans, you might change your pooling, you might change some of your configuration potentially, or how the AGVs are routed, how many AGVs go up to the parallel buffer and wait versus how many maybe hang back at the transfer point before they come up. So a lot of different tweaks, and it's kind of a elegant dance between how to optimize what's going out there in the yard for automation terminals, right? And you would definitely want to review your KPIs and rerun it, make some changes, and see if you made any improvements. So this has been a very important part of our work with Weibo. Okay, so here's an example of our 3D visualizer for operational monitoring. See what's going on, making sure everything's there, up and running. Look for any bottlenecks or any potential problems, so you can visually see it and make decisions, as well as the other dashboards and other things that you can see. And then we do have a our simulator to verify the operational performance. This will just be an example through our CyberLogitech simulator, what it looks like, and you can set up your scenarios and run them as much as you like. Okay, so I think that's the end of my slide deck. So I will open it up to Q&A at the appropriate time. But again, it was a pleasure and an honor to be able to speak with everyone here. So thank you very much.
Yes, thank you very much indeed. It was our pleasure to have you as a speaker. Please stay on hold as we will be having the panel discussion after the next presentation. 네, 그럼 첫 번째 세션의 마지막 연설문을
So let me invite the last speaker in the first session, Mr. Seung-nam Kim of Seoho, and he will share with us the port automation technology as we see in the case of Tuas Port. Please welcome him with a big hand. Good afternoon. I'm Kim Seung-nam of Seoho Electric. I'd like to thank you for being here despite busy schedules. And I'd like to thank the Ministry of Oceans and Fisheries as well as YGPA for hosting this important event. Seoho Electric has been working with Singapore over the last 2 decades. And we are being part of this new port project, the Tuas Port project, over the last 7 to 8 years. So this is the event we hosted October 1st this year at Tuas Port. Over the last 2 to 3 years, because of the pandemic, we had some difficulties, but we are working on various projects. One of them is BPA 2.0 and Tuas Phase 1 and Phase 2. We have provided equipment. I will focus my presentation on that. As you know, as for K crane, double trolley AGB, ALMG, those equipment are being used on the transportation end. We used trucks and how to automate those equipment and devices. Now, whether we will run them manually or we will do it operated remotely. Whether it's BPA project or TWS project, they are more or less the same. We use a K crane, double trolley, and as for yard crane, we use RMG, and we use vertical array. As for TWS, AGB was the starting point, and as for BPA 2-4, we started with the shuttle carrier manual one, and currently they have introduced in AGB. That is in progress. The Busan Port Authority will introduce in the 9 cranes, and Hanjin and Tusan have provided RMGs. This is the photo of BPA Phase 2-0, the project site. Now we are preparing for a pilot operation, and there are 44 units. They are on site, and we will soon start pilot operation. And this is a PSA TWS Phase 1-1. And if you are in this industry, you might have heard of this project. In Singapore, there are 3 or 4 terminals, Tanjung Pagar and Pasir and TWS will cover all those 3 existing terminals. As I mentioned by YGPA, K crane can handle as large as 10,000 TEUs in most of the cases. So the Busan port and the Gwangyang port need to go through some upgrade process. And the same goes true for Singapore. They have to upgrade their existing ports and terminals in order to accommodate larger vessels. But you know what? These days, people are relocating their ports into the central part of the country. And they are relocating all their existing terminals and port facilities to TWS by 2040. So about 50 berths, existing berths, and they will create 64 berths in TWS. That is a plan for them. But what will happen in 20 years' time, we do not know. But anyway, well, this is the first part of the phase 1. They are building 6 berths, and there are 160 AGBs and 28 double trolley K cranes. And there is a RMG 84 unit, but in this case, it is a single-side cantilever. And as for ANFID, that is an interface for external trucks, and there will be 27 blocks, and there will be a remote console. As you can see on the photos, on this side, there is a cantilever, there is an arm, and on the other side, there is no arm. So that is what I meant by a single-side cantilever. This is the east side of TWS project site. So if here is one vessel and the vertical arrangement, and this yellow part, that is the transfer zone for the transportation with external trucks. In typical AGBs, will have an interface here on this end, but in this case, well, we will use the entire area. So we don't have this space, but in the middle, we will have some space for AGBs. Given the characteristics of Singapore, well, the transshipment volume covers over 95% of the entire traffic. So this is the outcome of long and thoughtful consideration. And the current operation, the pilot operation, has not identified any specific issue as to that. Last year and the year before, because of the pandemic, for about 2 years, we have made any significant progress. But nevertheless, we are on track, and we will be able to. We were able to open 2 berths in October, And we successfully opened 2 birds in January. So the contract covers 6 different birds. Initial plan is to open all 6 birds by the end of this year. But anyway, so far we have opened 4 birds. This is a remote console. In Busan, most of the cases, the 40 units of RMG and crane without using the cantilever. But out of 4 fingers, only 1 finger will be used. What is interesting here is that, well, there will be about 18 birds. And 18 birds means the size of Busan Port. And we believe that about 250 RMG units and 180 K cranes. And all these equipment will be controlled at this control center, whether it's K crane or RMG. What is quite interesting is that the console can run 2 different equipment and the secondary trolley as well. So the point here is that we can produce a more diverse combination. Whether it's external trucks or K cranes, everything can be managed and run and maintained in this control tower, in this console. So we opened 2 birds in January, and October 2 birds. Then by the end of this year, we'll be able to open 2 more birds. And this is the completion. This will be the completion of 1-1, phase 1-1. But throughout the world, not that many AGVs are in operation, and there are not that many birds which are fully operated. So in the early stage, we might face more difficulties, especially the one I showed you, the K crane. We should cover the blocks as well, and a greater number of AGVs, whether it's FMS or something. Well, we have to supervise all those AGVs, and this will pose a new challenge for us. This is the DTQC technology on K crane side. We have 2 secondary trolleys. As you can see here, this is a whole new attempt for us. And for TUAS, this is a very first attempt as well to introduce this kind of technology. And other than China, this is the first ever project with this DTQC technology. So most of the cases, you will unload cargo and put it directly onto trucks. But in this case, we use a lashing platform. The lashing platform does coning and deconing. So when you load cargo onto a vessel, you should do it, this coning and deconing. Well, most of the cases, containers are stacked, 6 stack or 7 stack. But these days, well, we have taller K cranes, even 12 stacks. That means it is too tall that you cannot do it manually. That is why we have to do it automatically. We have to use semi-auto cone and auto cone. In the past, we had so many accidents and so severe injuries up until recently, but most of the cases are due to this work, the coning and deconing. But these days, at the top, we can do the coning and deconing, and after that, everything can be automated. And this work has continued from CTA days, and this is something we have done over the last 20 years. The difference here is that, as for the CTA, well, we have an operator, but now, these days, everything can be done remotely, and it is almost automated. So the manual part has been extremely limited. And going into details as to the technology, As you know, that we see the integration and convergence of technologies. So if you develop a new technology, then you can apply it and expand it onto other areas quite quickly. And autonomous driving has become extremely beneficial for us as well. The scanner, radar, camera, all those sensor technologies have been developed quite quickly as well. The video recognition and analytics solution from autonomous driving technology has been incorporated into our technology as well. In the past, we need to set up 2 or 3 computers, but with 25 cameras, with 7 PCs, the functionalities are all there. And we also have a scanner and a video recognition device. The 2 things, it is quite a lucky coincidence for us. In every factor, in every component, we have a camera and sensors. RMG is equipped with 25 cameras or 25 eyes, and then we can automatically recognize, we can capture what is recognized by those 25 eyes, and that is what I meant by video analytics solution. In addition to that, customers want to have a higher safety, productivity, and reliability. So the demand is getting higher. And the laser scanner is the upcoming technology as well. The laser scanner these days is quite different from what we saw 20 years ago. We have a way higher resolution. In the past, the difference or the error would be the 50 millimeters or 100 millimeters from 50 meters away. But now the difference has been reduced dramatically. We are talking about the automation of equipment and the component, but sensor production and video recognition, that is the area we are working on. And as for the laser scanner, well, we use this for AGV positioning and status detection as well as anti-collision. People believe that AGV is the simplest one because that is autonomous driving car. But as for crane, you have to go to where the vessel is. So you cannot operate it independently. So the gap in the position should be handled through adjustment. And I'd like to move on to RMG technology. Currently, it is almost done automatically. If you want to see the difference between now and 10 years ago and 20 years ago is we have this video analytics solution widely and actively used for the RMG technology these days. We have advanced autonomous driving robotic technology in place and available. Now, with the integration and convergence of technology, we see the advances in these areas as well. I think the challenge for us is the transfer zone, especially the trucks. There are 25,000 trucks for container shipping, and whether those cars can run properly within the port. And then the chassis formation and configuration is slightly different from one truck to another. That is why in TUI, we have introduced 3D sensor cameras. So in each part of this area, we will have 3D sensor cameras. So we will create blocks in the initial days, and we will recognize and detect the car number, the truck number, and we will check all the position and the location, and we will ensure security and safety as well. And this is the sample and example of a video analytics solution system. And you can see, this VA solution covers container detection, yard marking. We check the arrangement. And when NGB positioning is done, we check the gap vertically and horizontally so that we can ensure reliability and safety for the actual operation. So detection and recognition technology can be used to the maximum benefit based on how we use it. And the issues at hand I have identified so far is that in Korea we have some snowfalls. In Busan we do not have that heavy snowfall. And once or twice in a decade we would have snow. But cameras do not recognize that. So how to handle this? This is another challenge we have to consider. And the next one is the maintenance of the yard and AGB. If there is any yard marking and if there is any marking for AGB, well, that should be maintained properly. And another area of challenge is that given the structure of the terminal, that we have some IT personnel and we have some engineers and operators. But within the IP, well, there is an IT electric equipment and then another set of equipment and the system. Then moving on to truck and VA solution and 3D camera, well, with the truck auto operation, we do the alignment and we use the VA solution for this as well. And one of the newest technologies would be 3D camera. And using 3D camera, we can do the truck position detection, and we can through that we can protect the trucks. And for TWAS project, we use the camera quite extensively. Then we utilize cameras for remote operation to check the efficiency as well as productivity. And one of the challenge is the speed of camera or the advances of the camera. Think about the resolution of the camera in your smartphones. 10,000 pixels. In the past, well, that would cost you $1 million. But now we are moving into the age of gigabit. The backbone, terminal backbone should be 100 gigabits speed, and it will become even faster. So high performance of camera requires higher speed and traffic. And another challenge, one of the biggest challenge would be network security. Challenges would be network security. If there is any intrusion into the system, what we are going to do and how high the network security level should be. This is something we have to ponder upon. And down the road, on the DTQC and QC side, how to do the ship side automation and how to do the transport equipment automation, especially the electric introduction of the yard tractor. So this is the end of my presentation. Thank you. Thank you very much, CEO Kim Seung-nam of Seoul Electric. This is the end of the presentations prepared for session 1. Let us move on to the Q&A session. Now I would like to introduce the chair of the session as well as the panels. The moderator is Mr. Sang-hee Choi of KMI. And our presenters will join us for this panel discussion. We are joined by Mr. Ho Ko-shel, the CEO of Acunet. And we are also joined by Mr. Chet Payne of Cyber Logitech. Are you there? Can you hear me?
Are you here with us for the panel discussion?
Hello, everyone.
Yes, I can hear you. Thank you.
Then we are joined by Mr. Seung-nam Kim of Seoul Electric. Last but not the least, we are joined by Dr. Jong-won Park. Then I'd like to hand the floor over to the moderator.
So first, I would like to thank the speakers for their insightful presentation. Regarding the first and second presentations, We talked about automation of ports, more of the software and the operation of ports. The third presentation was more focused on the hardware, I think. But also, the conclusion is that software was very important, that technology is essential to the advancement of ports these days. To the first presenter, you talked about after building the terminal using digital twins to monitor real-time operations in the virtual world and how to assess the performance of ports. So that was very insightful. Thank you, Mr. Hogoshuet. And then second, Mr. Chad Payne talked about the operational system of automated ports. Talked in how to manage the equipment, talked about the emulation and simulation tests to validate the performance, and also planning the operations to enhance the efficiency of ports. And then Mr. Kim of Soho Electric, the third presenter, talked about the new port in Busan and also about its cooperation with Singapore, talked about each element of the equipment mix and how technology is being used to automate and control the equipment. And so I would like to ask Mr. Park, the panelist from CRISO, to give us some comments on the three presentations. Mr. Park? Thank you for the introduction. My name is Jongwon Park, and I am from CRISO. And I would like to thank the presenters for giving us valuable insights to some of the issues and the technological development that we are experiencing in automated ports. My focus is IoT in port operations, so that is my area of interest. And Mr. Kim mentioned about the cranes, that there are many cameras and sensors installed, and that the data traffic in ports is exploding. So there is the need to introduce 5G and talked about network security. He highlighted the importance and challenge of network security. And I think those two elements are, of course, key to port operation. The high-tech group last year end said that, so more recently, people are thinking of security in diverse areas, not just in physical security, but the network security, data security, because the IT systems can be vulnerable to external attacks. And we are actually seeing higher frequency and more intense attacks to the IT systems of port. And so I think that is an area that we must prepare from now on. And we need to address this issue to prevent any crisis in the future. Also, as telco technology is advanced, we have 5G now. So 5G was introduced already several years ago, but 5G related solutions are more recent. And I think there will be more software and solutions for IoT as well. I mean, digital twin is one aspect because connection is very important for a successful digital twin. And so connection with TOS and other vendors. And if there is more higher telco technology and connection is strengthened, we can simulate and emulate and try more things out in the digital twin as well. So I think that is another direction that we need to look at. Thank you.
Dr. Park didn't ask any questions here. So I prepared some questions for the speakers. To Dr. Hogoshuet, I have one question. You mentioned that automation should be safe and secure, and operational performance and operational cost reduction, and the efficiency, and automation has great benefits in those areas. So in the virtual environment, we can check the performance using digital twin And you shared with us some use cases. That was very impressive, especially the utilization of a digital twin and for the visualization and equipment control and analytics and decision-making support. So I believe a digital twin enables all these features. And among them, I believe what is the most important is analysis. And by doing analysis, typically digital twin offers those 5 features, but digital twin is there to allow us to predict and look into the future. And to the benefit of terminal operation, if we can forecast what's going to happen in the future, then we can capture that in our actual terminal operation for the present. I think, well, that will be one of the most important features down the road. Then based on this analyzed information, and this predictive information for the sake of operational efficiency, safety and security and reliability, or cost reduction. I'd like to know if there has been any case or the use cases where this predictive information has been utilized for higher efficiency or predictability and safety.
Yes, thank you very much, both of you, for your conclusions and summaries of our speeches and presentations. I think it fits very good. To your question about the IoT, this has to be put into operation more and more. Yes, this is part of the digital twin. I haven't mentioned it directly, but the digital twin is not only using data from the TOS, from the terminal operating system, it's also using machine data from the equipment, all these things. And this is a very important part. So you asked about predictive things that we can do with a digital twin. The first thing is we may find out gaps between what the TOS wants, what happens, and what is really done on the terminal. So one terminal operator, he is really expecting more visualization of these gaps by comparing, okay, a TOS gave a job to a piece of equipment, and the TOS is waiting. What is happening now? He has to wait until the equipment mentioned, okay, I'm ready. But on the other side, perhaps you see this equipment, the engine is not running at the moment. The driver perhaps makes a break or whatever. So this can be shown directly in the digital twin. This is some of these alert things that I mentioned. This about the IoT. And to your question about the prediction can be in many ways. First thing is really you may simulate based on the current planning, on the current situation on the terminal, what will happen in the next 5-6 hours. Will the vessel be finished in time? There will be an automated, in this case that I mentioned with the Eurogate group. There will be what-if simulations in the background all the time, looking whether the operation will fulfill the goals. And the other one is more on the equipment side. This will be also what we call the predictive maintenance. So if you have a lot of data sampled by the history of the operation, then you may see if there is a special combination of sensor data, the probability of a breakdown of this equipment increases. So therefore, you may stop this equipment before the failure occurs and yes, get it out of operation. You don't need to have a crane in these automated terminals, a big crane in the middle of the block, and something happens. A breakdown comes. Yeah, if you see this may come within the next hours, you can put them to the maintenance position in the block, and handle before really this thing will happen. These are two small examples. Within the Eurogate group, we defined some 40 to 50 use cases where the users mentioned what they want to do with this digital twin. And this is very impressive because when we started it, we didn't know whether people were able to answer this question. But the workshops were very good and they really had a lot of ideas. So it's not done by either the government, the port operators, directors, or it's coming up really from the people in the field, the benefits that they feel having with this technology. And main thing, I mentioned it, is don't show them bits and bytes. Yes? Dashboards, as we saw them, is the first way, and the way that people are thinking in is really in pictures. If they look at the operation and something is blinking because there might be a breakdown coming up.
네,
Thank you for the great answer. So I have a question for Mr. Chad Payne now, the second presenter today. You talked about the BGPA terminal. You talked about a real case. There's the AGV traveling routing. I understand that it is different from existing programs. So Tuasport also said that they used something similar to BGPA. So I'm really interested in this method. So when you do the simulation and emulation, I'm sure there would be some pros and cons. So I don't think this will be something that has higher efficiency all the time. Maybe there will be some disadvantage because routings can become longer, so maybe you will need a higher number of equipment. So I'm interested to know the pros and cons. Can you maybe talk about that?
So let me just clarify the question. It's the pros and cons of working with our current FMS and ECS provider. Is that right? Okay, so all right, I'll just kind of talk about for Beibu. Yes, we work with a third party based FMS that also manages the ECS, but we've been working with them quite some time in terms of setting up not only our simulations but then going into the emulation phase. What we focus on is how our TOS can minimize the costs and improve the productivity of the terminal by minimizing unproductive moves, right? Making sure that we're dispatching the right jobs to the right equipment, minimizing stuff like rehandles, reshuffling, within our TOS optimization algorithm. There is some issues with Beibu in that they have a very long, let's say the RTG cantilever block. It is a 500 meters yard block. So there's only two ARMGs covering that. That's a little bit longer than I've worked with in my past, or a good bit longer. So there is some operational, KPIs that we have yet to reach, and it just focuses on the importance of the simulation and emulation, and tweaking the system to improve it and making the most optimized decisions between not only the TOS but the ECS and FMS. So things take time, right? To adjust and improve and stabilize. You spend years on the simulation, emulation, getting ready for the go live, but even after the go live, there's certainly adjustments that you can make to get up to the KPIs. So all parties need to be continuously active on the terminal project and always working to improve the operational efficiencies and the overall KPIs. It takes a lot of time and effort by all the parties to bump up the KPIs a small bit, but it just has to be a continuous process to get to where you need. So yeah.
예, 제가
So, yeah, I have another question for you. The AGV in the K, when it moves to the yard, there is a connected point. So is it in the seaside block? So that is the usual automation AGV system in the past. But Beibu and to us, I understand, the AGV can go into the block. Yeah. 네,
Cantilever,
Okay.
yes.
So I was wondering, what is the pro and con of this different AGV system?
Say with your traditional kind of, or at least traditional to me, kind of your water side and land side transfer points, you really separate out your AGVs, right? They're all located more on the water side. They're only coming up to the transfer points, and so they're going to have a little bit more of a short distance, to go up to the transfer point, and then eventually go up, to the vessel, or come back as needed. So that is, a little bit more of an optimization on the AGV side in terms of travel distance, in terms of productivity, in terms of making sure that you meet the key crane. But it also puts more, let's say, I don't want to say pressure, but also puts a little bit more emphasis on the yard cranes need to be super efficient in terms of their decisions to be able to meet the AGVs. So your yard crane can be a lot more optimized in terms of their productivity, in terms of travel distance, minimizing any breakdowns. When you have your end loading points, you really get in some trouble. When your water side breaks down and you got a bunch of loads to go up there from that. But it more so optimizes your yard crane productivity. Yes, it's going to increase your AGV driving distance. And also just from a configuration standpoint, one of the cons is that the terminal is going to have more space, in between the yard blocks, right? The transfer points can be very close together. You can stack a lot, next to each other with the 4 or 5 transfer points on the end. But when you have the driving lanes, for the AGVs and the external trucks on the side loading cantilever, there's single and there's dual, of course. Your yard configuration needs to be able to support wider, space, for all the ASC, because there's just more space for AGV, traveling and the working lane, but certainly can give you very good productivity on your ASCs or your, in this case, RGB cantilevers.
So one impression from my side, the Tuas terminal, and I think the other one here as well, the other part, it was mentioned that they had a very high transshipment share. So containers that are coming from the seaside and going to the seaside. And in this case, the land side transfer point has much lower workload than the seaside. So therefore, in Altenwerder, in Hamburg, this automated terminal, they have 2 cranes who can, one big crane and one small crane. Both may work on the water side. So the whole workload can be done by both cranes. If you would do it in the Tuas terminal, the seaside terminal, the seaside transfer point had to do, let's say, 90 to 95% of all workload, and this is not possible. So it's a good idea to have this cantilevered cranes. Typically in transshipment terminals, you do have you more often see the parallel layout of the terminal.
Thank you. Now I'd like to turn to Mr. Kim. Well, we use that cantilever in the TUAs. Per block, we have seaside and landside. Most of the cases, we use the seaside ones. So if the transshipment accounts for 95%, then you use the front crane. The AGB interface area within the same block, if you have 4 lanes front and 4 lanes in the back, that works for Busan. But if 95% would use the AGB and 5% is land side, in the case the AGB interface area would be too small. So I think the approach was brilliant. Per crane, we have 12 rows. So in total, we have 24 rows in a block, and we provide AGB services using 600 kilometers of distance. The shortcoming here is that we need 2 times more AGBs. As we saw, we have 84 units of RMG, and now we have 160 AGBs. And if you remember the layout in the block, the truck interface, interfeed zone, or transport zone, we have 84 units and 43 units. About 60% is for external trucks, and the remaining is used as a block. So in terms of efficiency, it's very efficient and the efficiency is very high. But if we have to have 16 berths, then we have to have more than 500 AGBs. And the plan is to use all those 500 AGBs. But if those 500 AGBs are running within that limited space, we are running these 4 berths and we are out of space. So we don't know what future holds, but that will be addressed over time as well. So that's the shortcoming I'd like to share with you.
The first session, we had 3 presentations, and we had a productive Q&A session as well. Maybe it's time to open up to the floor. Do we have any questions from the floor? Yes, we will get a microphone to you. So I am an engineer, and my name is Han-gil Kim, and we talked about productivity, and as an engineer, we will try to incorporate your insights today in order to enhance productivity. Yard efficiency is impacted by natural environment and location. So it can be different from place to place. So it can be different in Europe or in Korea. It's very seasonal. We have very cold winters. The productivity can vary across different ports. When you conduct the simulation for the Busan new port or Gwangyang port, they are 2 very different, even they're both ports in Korea. Because I think the temperature in Gwangyang is more stable than Busan. And so for the for the carriers in Busan, I think they are finding it more difficult to manage their fleet rather than Gwangyang. So when you conduct a simulation, do you incorporate these different natural environmental factors like the wind and the tide and so on? Mr. Schwett?
Yes, of course, we have to. Otherwise, we only have operation on sunny weather, and this won't help the terminal with high snow, a lot of snow. So in Altenwerder terminal, it was quite funny because after starting the terminal, when the first winter came, they had real problems with the ice, because it was slippery and the AGVs didn't know where they were. So they have to recalibrate very often, which put the productivity down. The result was that they built some AGVs with some sand throwers. So if the ice is on the ground, the AGVs have to go there and de-ice the terminal. No, but in the simulation, of course, you have to have a look at this as well. You have to look at the environmental situation and yes, use yes, speed and factors according to these environmental factors, yes. So we did for one example, we did one simulation last year for the northern corridor. If you use in ice-free times the corridor above Russia to transport containers from Asia to Europe, this was a very special simulation, but of course it won't work all the time, because if the sea is frozen, then you are not able to run it.
예.
So I'd like to thank our three speakers once again. I really want to thank the participant who asked a question. So due to time constraints, we have to conclude the first session. Thank you very much. Thank you. This is the end of session 1. We will take a 10-minute break. Then we will continue at 10 to 3. Thank you.
our keynote speaker during the afternoon session as well. So please stay tuned. Now we will begin the second session, which is themed Ever Developing Intelligent Ports. Currently, this event is being aired online on the official YouTube channel of the Yeosu Gwangyang Port Authority. So I will just read you some comments that are online. I am a industry member, and thank you for providing insights regarding automation of ports. So now I would like to begin the second session. The first presenter is Ms. Saran Turan, and she is from Hexagon. Please give her a big round of applause.
Hello, my name is Saran Turan, as announced, and I'm coming on behalf of Hexagon. I will quickly remove this. As you can probably tell, I'm a little excited. It's amazing to be here with all of you who are very experienced in smart sites, smart technologies, and especially on ports. So I'm looking forward to sharing our technology, and then afterwards looking forward to the panel session where we can share more question-based answers. So I want to start with a very short introduction to Hexagon, and then our approach to smart sites in general, and then what we offer in terms of smart ports specifically. You may be already familiar with the name Hexagon. It's a global leader in digital reality solutions. We aim to empower autonomous, sustainable future by putting all of the data you already have available in your organizations into work. Here we say future, but I think we can all agree that it's actually today. When I first heard about this event, I was very happy because we hear a lot of events based on either ports or other transportation-focused solutions, but it's always the starting point is that you have to convince customers or authorities that digital reality is today and they need to convert to these kind of solutions. But when I heard that this event is actually called Smart Ports, I was very pleased that I don't need to convince anyone about anything. You're aware that this is today, and the question is how we can go into making sure we are following the latest trends. Hexagon is a very large company with offices all over the world and amongst different technologies and different branches. And there's actually an office in Seoul, Korea as well, which is very close to this hotel where my colleagues are working from. And it has 4 pillars: innovation, relevancy, stability, and sustainability in all of our solutions, and also hardware combined. I want to not focus on these too much as I don't have a lot of time, but on the road to autonomy, we make sure to start with both hardware and software solutions and combine this in a way that is relevant to our customers to be able to answer their needs correctly and efficiently. And here you can see in the digitalization process across Hexagon, we touch a lot of different parts. So we can start from manufacturing, which is very relevant in a ports use case, and then combine that with engineering, both in terms of data and decision making, as other panelists and speakers has already noted before. And my focus more mainly on the geospatial aspect of these solutions. So for this purpose, I want to give a very brief introduction to smart sites as a concept, which I think you're all familiar with. But one thing I realized in the previous presentations were, I think the focus were more on the operations point of view, which is very relevant and important in terms of having a smart site or a smart port. But what we want to add on top of that is how we can actually connect to these systems that are already existing in your organizations, and then have a map-based view combined with dashboards so that it's very easy to perceive on the first look through a smart digital reality-based system. So here, what we aim to do is to create a digital twin of your world in a way that when you have a look at it, you should mistake it as a picture. So this is the quality we expect from both the data that we're displaying and also the visualization that our software offers. Why do we have the need for smart sites? I think we touched on the operations base, but the problem that we were mainly facing with from a lot of our customers or prospects was they kept telling us they have a lot of data. It's in different parts of the organization, it's in silos, it's very interesting to more than one department, but there's no centralized system where they can arrange this in a way that people only who have access rights to certain data can access it, but also in a way that it makes sense for them to interact with. So for example, while a manager might be interested in dashboards that are based on a certain data set because he needs to make decisions based on this, another type of user, for example, a field worker, can be interested in a different interaction. So we wanted to start with this GeoOps challenge where we start with static or dynamic data that is lying around in an organization and then see how we can turn this into actionable intelligence that is available to different types of users. And here you can see one of the things that makes it very interesting is it's not a linear system. You don't start off with the data, display it, and leave it at that. We actually have a cycle in a sense that through operational logic, we feed it back to our system so that it's always up-to-date data that your users can interact with. So our vision is to have one single operational view through, as you can see, the images here, through different types of visualizations that are relevant for different types of data that are available for a smart site, or specifically in this case for a smart port. I don't want to lose too much time as I don't have a lot of it, but here I refer to a bunch of different data formats which are all relevant in a ports use case, because it can be that, for example, you may want to make some changes in the architecture of a port, or you have some GIS data that you want to visualize and then make some operations based on it, or this part was actually touched by other speakers as well, connect to some IoT or real-time feeds to have a very dynamic system that is completely up to date at all times. So for this purpose, we come to you with Hexagon Smart Site Solution. I cannot continue. That is based on a library that is called Luciad, which is a part of Hexagon portfolio. So here I will show one video which is making use of our Luciad RIA solution, and then it's actually based on a smart city use case where you can see transportation buses moving around dynamically combined with a very realistic 3D view of a city. I'm not going to focus too much on this one because I'm actually more interested in showing you this. So here we're actually seeing a petrochemical plant, which I think also from a port's perspective is very interesting because thanks to this conference, I was actually able to come here a few days earlier and then have a few other meetings with some Korean customers as well. So I had the pleasure to go to Ulsan, to Korea Zinc, which is an existing Luciad customer that are very happy with our solutions. And I was very excited when I was landing on the plane to see the port and to all of the detail in terms of the data we try to display on our solutions. So here you can see a petrochemical plant with some 3D data coming from different sources. So we have meshes, point clouds, a fully interactable way of being able to display data through also panoramic images. So while it's very important to have the operational aspect, the connection to it, it's also very interesting to have the facility in full detail with 100% digital twin. And I will explain what use cases can be solved by having such a solution. Here, I have to apologize, I'm a software engineer, so I'm amazed by all the details of software, so I may go a bit too much detail into what it can do. Please stop me if I do, but here we have a very detailed visualization of actually, this is a company called BASF. You may be already familiar with it. They have a quite large facility in Port of Antwerp, which was also mentioned a bit earlier in the keynote speech. So here we wanted to demonstrate what you can do making use of Luciad solutions in terms of, for example, getting together a bunch of different data sets, and let's say you want to have an understanding of the changes that have occurred, let's say in a port use case for this conference, in certain infrastructure related components in a port. So this can be, for example, due to accidents or due to weather conditions. What you can do is have an understanding of these changes and then act accordingly. Or you may want to look at so this can also be a ship, it can be a container, or it can be a facility. It's completely up to you. You may want to have an understanding of, for example, through a very detailed 3D modeling that is introduced into the software, you can have a look around into your data and then see in 3 of the dimensions what resides inside this model. So it's not just that we put your data in a very good quality, but we also make sure for you to have an interaction with it. This is something very interesting to me personally as well, is it gives you the, sorry, the video is a bit fast, but it gives you the possibility of interacting with a 3D model, for example, in a way that you want to perform some maintenance operations in certain parts of the port. Normally what you can do is you can say, okay, we know the location that we want to perform this operation. Let's assign someone, a field worker, who can take care of this, and then send this person to that point. He makes the analysis and then comes back, reports it somewhere, and then you send again to decide which kind of tools you need to use and then how you can fix the issues there. This is a long process, and long means time consuming, so money consuming. We want to automate this in a way that you can actually look at a 3D map, make the measurements as it was shown just a while ago, and then decide, okay, it's 5 meters high, probably I'm going to need a crane or a ladder, and then this person needs such and such equipment, and you automate the process of sending this person to that area for fixing. And this is only one of the tools. There's a bunch of other options that are coming from actually 3D visualization technology, which opens up a lot of new possibilities in terms of use cases. So what we thought was relevant, and actually I want to be very honest here, I'm not a ports expert. So for me, it was very interesting to listen to all of the three speakers before, and I'm sure it's going to be the same for the ones that are coming up as well. These are the scenarios that we think are relevant for smart ports, but actually, sky is the limit. As long as we keep talking to our customers and prospects, they actually come up with a lot of scenarios where we see it fit to integrate into our solutions. And even though we want to sell a solution that is slightly out of the box, so it's easy to start off with, we still make it very tailored for each organization. As it was mentioned before, unlike airports, there's no standards for the data that is associated or the processes associated with ports, which means we have to be very dynamic. And this is something we're very proud of. We can connect to any type of data and then actually connect and work with your existing systems. So here we think reservation planning is an interesting use case for ports, which can be put onto a map combined with real-time asset tracking. So this can be for cargo, container, or people in a facility to make sure that there are no injuries, or if there are some, for example, an incident, a fire, you may have the ability to find the closest fire extinguisher and then send the person to that area. These ones I will skip a bit fast, as I don't want to lose too much time, and show you the actual customers that are making use of it. Maybe one last thing to include is combined with a lot of geospatial-based data. We also have the possibility to integrate, for example, connections to security camera footages. So then again, in a very automated system, you can just have a look into an alert that pops up in a certain area. You click on a security camera, you directly see the footage, and then you can decide if this was a wrong alert or if it requires some action from your side into that area. So here we have one example. This part is not directly a smart port use case, but it demonstrates this security camera use case that I was talking about. So we have some data regarding a port, and then we have the direct connection to a security camera footage combined with the line of sight, the yellow one you can see below, that demonstrates the point of view of the security camera. I must say the map you're seeing is a few years old, as it was a bit of an older demo, but the visualization capabilities you've already seen in the previous videos. As I said, Hexagon is quite large, and smart sites, and more specifically smart ports, is actually a part of what we cover in our customers' base. Maybe one thing you might have heard in terms of Hexagon is that with S-Oil Aramco, it's one of our, again, biggest customers at this moment, as they are planning to implement a digital twin software using Hexagon technology. And we have a very long list of references, some of them based on this Luciad portfolio that I mentioned to you, but also a lot of other ones ranging from, for example, photogrammetry. So we have also tools that allow you to make some analysis on imagery data, or some dashboarding and so on as well. So one of these port use cases is Port of Lisbon. So here you can see a solution, again, a map-based solution, which allows you to do navigation and then have an understanding of marine and land infrastructure, and then basically make sure that it's a secure environment, and then all the events and the projects can easily be tracked from the software and also updated live. Another customer here is Bremen Port. So the Smart Port Bremen makes use of Luciad technology. Again, one thing I want to mention is Luciad actually comes into play as it can either be your solution partner for a port, in a sense that you can use our technology combined with either other Hexagon portfolio solutions, or we can implement a solution for you. So here it's making use of this GeoMedia solution from, again, Hexagon. So there you can actually visualize the data for the water levels of a port, and then have an understanding of if there are some risks regarding the level of the water. So for example, if there's a risk for flooding, then you can easily generate alerts, or even create a pipeline that automates evacuation processes through automatic generation of routes. Again, in Port of Tallinn, one of the use cases is asset management, as it is very important, and it was mentioned before. Sometimes the plans change in terms of how a container is supposed to move along its route, and then things are lost, or at least, if not lost, it's not clear to customers. So through asset management and tracking, we have the possibility of tracking objects on a live 3D map at all times. And this is done in Port of Tallinn. Again, a bit closer to here, Maritime and Port Authority of Singapore. So this is an interesting use case, I think, which is based on garbage collection or management, which is also one of the biggest issues regarding ports. So here I wanted to show a few different things rather than simply just talking about the input and output to a port. So for the tracking of garbage from the vessels, Singapore Maritime and Port Authority is making use of, again, Luciad portfolio for its solutions. And then we have another use case in Port of Huelva in Spain. Again, we have a map-based solution where they're making use of Luciad solutions. And the same goes for another port management system, Agata Port, another city in Spain. And then another part which I wouldn't focus too much on is, again, vessel tracking, as our focus is maritime and ports. Basically, as I said, the sky is the limit. As long as you either have all this data available, or you use, again, Hexagon technologies to record this data and have a fully active digital twin. Thank you so much. I believe I cannot have questions now, but looking forward to hearing from you. Thank you.
Thank you very much, Ms. Saran Turan, for your insightful presentation. As she mentioned, we will address questions from the floor through the Q&A session and panel discussion. Now, I'd like to invite Mr. Kim Tae-yong of Rovigos, and his presentation is titled IoT-based intelligent port and the future of its convergence with UAM industry. Please welcome him with a big hand. Good afternoon, ladies and gentlemen. I'm Kim Tae-yong, CEO of Rovigos. I'm very nice to meet you. Today, I'd like to talk about the future with the Smart Port Artificial Intelligence System and a UAM. You can see the English translation of the presentation material. We are deeply interested in the smart city. My company is keenly interested. And the smart city market is expected to grow exponentially. This means that smart city has garnered a lot of attention throughout the world, and it has been applied across the board. So across the board, in a city life, a smart city technology is being actively applied, and our focus is on the port. Korea has about 60 ports, and there are about 330 transportation and container-related companies, and per terminal, about 1 million containers are handled per year. This shows that how big the port industry's contribution to the national economy is. According to the 4th National Port Basic Plan, the Korea's port infrastructure is not competitive enough, especially in terms of the infrastructure. It lags far behind other countries. It ranked only 24th. And in terms of the logistics industry's performance and efficiency, we lag behind Japan, Singapore, and Hong Kong. This shows that we have such a long way to go, although we have high dependency and reliance on the port and logistics industry. Then my company considers how to tackle this problem. And we can summarize what's done at port in 3 phases. The first is, well, in order to have a better understanding of the problem at hand, we have to understand that at harbor containers and trucks should wait for a long time, and they need to have access to the vehicle terminal, and they are receiving documents and the permit to get into the terminal. It takes about 2 to 30 minutes, and even after the handover and take over the document, they have to go to a specific spot for the loading and unloading. And this is the area we want to improve efficiency. The container-related automation system has been introduced quite extensively, but the focus has been more on the crane. But my company's focus is on other parts, other areas. That is why we developed the port terminal JIT, or just-in-time solution, for operational productivity improvement and cost reduction. So typically, truck drivers would work 10 hours a day, and they are wasting 20 to 30% of their daily average work hours because they have to wait at port. So this is translated into an average of $1,000 per month. If our solution can successfully address this issue, then this will be to the benefit of truck drivers as well. So we conducted a pilot test at Busan Port. So we conducted a pilot test in Busan Port, and more than 100,000 container vehicles who participated. So we were able to reduce the waiting time by 15%. 15% might be ignorable, but well, to some, 15% is quite considerable. So I think the crane automation should be put together with utilization of data in other areas as well. So my company is focused on this area, port terminal JIT work optimization solution. We are offering AI solutions, especially the systems used as terminal are mostly embedded. So rather than changing and replacing those systems, we'd like to integrate that with a cloud-based analytic platform to offer our data analytics. So we are expanding our business into a platform business. And we are providing in container and truck data, the number of containers, and we are integrated with the Rovo systems in order to improve the efficiency by 1 to 10%, and this will lead to the cost saving amounting to millions of dollars on the part of the businesses. And one of the things we came to see is that there is a possibility and opportunity for a control system. And by offering this control system, that we can offer the information related to the location and the position of the trucks and the times we can save at every stop and every friction. And this is the area we are making dedicated effort. And under the theme of development, at the national level, there is a joint effort in Busan. In Busan, the UAM Ecosystem Forum, in few days, in a few days. Well, here the focus will be on 3S Sky Seashore Integrated Global Urban Mobility, Air Mobility. So this shows the level of attention from the government. And the port optimization system will be the main focus down the road. The fourth section here, the body port, is like a runway for airplanes. So various business models are under development. And you might not know what UAM is, so this is a brief overview of a UAM. UAM represents urban air mobility. Many countries are rushing to develop this UAM. This will be as one of the keywords, especially for the port industry. Those who are in the port industry might think that port would need a UAM, but in 10 years' time and 20 years' time, UAM will be actively used in the port industry as well. And then there are quite interesting photos. Container handling port. Might believe that they wouldn't need this kind of UAM, but in the middle, there is a UAM which can carry as heavy as 130 tons of cargo. So the UAM can be used for the optimization of a port or country-to-country container transportation rather than using vessels only, rather than using the seaborne transportation now that we can use. We have the option of airborne transportation as well. So this is a global trend. So these are some of the advantages of the UAM. You don't have to worry about the traffic or traffic jam. And the condition of the road does not affect the efficiency and the effectiveness of a UAM, especially in Northeast Asia, in Southeast Asia, and in Africa. The road condition is not so good. But since we use the airborne transportation in this case, you don't have to consider the conditions of the road. So here are some great photos of the UAM. So a UAM in the foreseeable future will carry people. And this will be commonplace in 10 years' time or 20 years' time. Many companies are working on developing the aircraft. The market is expected to grow, and even Hyundai has built an aircraft. This is the vertiport. So this is like a runway for aircraft. So vertiport will be commonplace for the use of a UAM in the downtown area, in the urban area. In Korea, UAM is dubbed as KUAM. And this is the roadmap for KUAM. This is what is pursued by the Ministry of Transportation in Korea. And by 2035, 43,000 people will be carried by UAM. And the country is also considering how much should be charged per kilometer. And by 2035, about 145,000 people per day will use UAM. This is the forecast by the national government. This shows the level of interest and attention and investment by the country and by the people. And after the demonstration project by 2025 and 2030 and 2035, that will become more practical. And based on this, in collaboration with the UAM industry, we'd like to develop one all-in-one smart integrated solution for air logistics management. And I believe the technological development will be quite active, not just in Busan, but also in Incheon, Ulsan, and various other port cities in Korea. And then this is the technology overview. Through data acquisition, and it will run on the cloud solution and cloud system. So optimization system will be done utilizing AI solution. Along with this, we will further expand the port-related system so that we can integrate the UA system and the port system in order to ensure optimization solution for both. So once we acquire and collect the data, then we will work based on the data cloud. And as for the AI solutions, but we will use that AI solutions for the user services down the road. And this is the application we envision. So this is actually used for demonstration tasks and so on. And I'd like to ask for your continued interest in the UAM industry. My company is a startup. Now we have 15 members within the company. So as a startup, we'd like to continue to work with the government and the government agencies as well as various other industries. If there is an opportunity, we'd like to take part in as a full member so that we can make the port industry smarter. We are working in other countries as well, not just in Korea. Other than incorporation in Korea, we have taken part in the various competitions in Singapore and other nations as well in order to demonstrate our technological capabilities. And we have a clear vision of the UAM industry in relation to the smart city and in relation to ports. We are actively developing technologies, and we have taken part in the UAM Global Challenge, and there is KUAM Grand Challenge Korea. We participated in both, and we are working and active. We are quite active not just in Korea but also in South Africa, as well as Colombia. Many people in Southeast Asia use computers, and we have such a great exposure to mobile technology, but Southeast Asia, the people there, well, they jumped right into the 4th generation or 5th generation communication technology rather than going through the stage of the 2nd generation and the 3rd generation. The thing is that those countries, well, do not have a well-established on land and inland transportation. That means that they can go directly into airborne transportation. That is the potential we see in Africa and Latin America. Of course, but we have seen such great advancement in Singapore as well. So we are working in this area. Thank you very much for your attention. This is the end of my presentation. Thank you. Thank you, Mr. Kim, for your presentation. Now, I'd like to turn to our third speaker who is joining us online.
We have the CEO and co-founder, Colonel Tenuvu of Awake AI. He will be joining online and talking about Smart Port as a Service.
My name is Colonel Tenuvu. I'm the CEO and co-founder of Awake AI. We have created the biggest innovation since containers are moving from sail to steam, and we call this Smart Port as a Service. Our background is from Rolls-Royce digital business, so we were the team that created the world's first remote controlled and autonomous vessels. And then we realized that these vessels will come to port and wait like everybody else. Port of Rotterdam had scanned the whole world looking for a team to help them, and they chose Awake AI as their development team in the Digital Twin project. We have also been selected by Business Finland as the growth engine company in Finland, and Frost & Sullivan awarded the company with Entrepreneurial Company of the Year award last year. Besides the team itself and the company, we have created an ecosystem of over 100 companies in the smart port and shipping ecosystem. So the main idea here is how to create the network effect and learning effect. We have customers, port authorities, terminal operators, shipping companies, and cargo owners that bring the use cases that we then connect with other software companies, technology partners, and research companies. So you're all welcome to join this ecosystem and solve the use cases fastest in the industry. What we actually do is that we are making the maritime logistics sustainable and intelligent in 4 different phases. It all starts from enabling the collaboration and transparency. So today you have the actors in silos whereas we have developed the platform, the APIs, and web and mobile applications to enable everybody to work together. Then after that, in the second phase, you can start to optimize the operations and offer new digital services. We have created 2 AI-based SaaS products for planning and prediction. Then on the third phase, you can start to automate some of these processes. And finally, in the fourth phase, some of these processes will be autonomous, so they operate without people in the loop. The first solution we built was actually called SmartPort as a Service. So if you go on Google Play and App Store, you will find that application there. It's free of charge. The main purpose is how to move everybody from communicating with emails and phone calls, faxes and WhatsApp messages into having one centralized way of communication. So here, every time a vessel is approaching the port, a communication channel is automatically triggered. We have bots generating messages to it, and you can see the latest predictions of all events through the port, and people can communicate publicly and privately. That capability is built on top of the data platform we have built globally. So we are a certified AWS partner that has built the most trusted platform for sea, port, and land interfaces. We can scale this to any part of the world in a matter of days. You can also find our AI-based predictions globally. So we predict the arrival times of the vessels, departure times, many weeks before actually the arrival. Our relative prediction area is less than 5%, and it's about 80% more accurate than you see currently everybody using. So feel free to try those out as well. Then we feed those predictions to our planning solution. So the AI is generating the port call plans automatically, and then it warns actors if there are overlapping plans or changes. This is the most efficient way to actually communicate the changes for the entire port communities. So everybody knows in real time, the truck drivers, the ship operators, everybody, when you make changes in the plans or when there are delays. This is a solution that we launched together with Port of Gothenburg, 2021, which is the biggest port in the Nordics. You can have all the relevant operational data in here, cranes, people, trucks, all the equipment that is needed. You can reserve the berths and fairways as needed. And this can be seamlessly integrated into national single windows, where that is now coming next year and the year after. And you can connect this to automatically through an API to any other system that you may be using, like terminal operating systems or port community systems. So the whole point of these 2 AI-based SaaS products is to create an analytics-assisted operations. So we link into AIS, terminal operating systems, national single windows, port community systems to derive these prediction services on arrival times, departure times, completion times. Then we feed those predictions to the planning solution, and they can be fed back to the original system as recommendations. So this is a continuous feedback loop that creates this analytics-assisted operations. We have taken this even further. So in Hamburg, we created the world's first automated schedule estimation service. So recommended time of arrivals and departures. So we analyze all the arriving vessels, departing vessels, berth occupancies, and tidal windows. And our AI is giving out these just-in-time recommendations for all parties in real time, 24/7. It takes into account all the passing restrictions, wind band restrictions, bridge requirements, automates the tide window computation and everything. When the vessel has berthed, we have created a range of computer vision solutions to track the asset movements on cars, trucks, trains, trailers, bulk goods, containers, anything really that when they have entered an area, moved or exited the area. Or what's the real-time count for containers in a stack, for example. So we are a global partner with Intel on this solution. Then you can visualize that. Previously, we saw good examples of digital twins. So you can visualize those models and details in the digital twins. Then, for example, show me the cargo flow through any given area, or what's the status of loading and unloading, or where are my dangerous goods at any given time. Valencia and Livorno are challenged by landside congestion. So here we are calculating the cargo exchange and cargo coming to the ports many days and weeks in advance. We predict the arrival time to the berth, the discharge times from the vessel, and even exit times by truck. Then we can simulate that cargo flow and congestion up to 4 weeks forward, and then give the truck drivers and rail operators the exact time when they should be picking up the goods so that they are not stuck in congestion. With the European Space Agency, we have created the leading marketplace for automating the buying and selling of port services and products. So when you are implementing a new national single windows, please consider the marketplace as a value-added service to automate all these commercial processes, all the reporting, all the invoicing, all the buying and selling related processes can be fully integrated into the national single windows and speed up the adoption and development of a national single window globally. With Port of Rotterdam and Port of Antwerp, we are working on their digital twin for smart logistics. And here we go all the way to enabling autonomous traffic to come to ports. On Rotterdam side, it's more the ocean-going vessels, and in Antwerp, it's more the inland vessels and barges that want to be coming to the port and automate all the machine-to-machine communication that they have. So today you have people talking to each other with VHF, and in the future there is no people on board the vessels. So here we're automating all that machine-to-machine communication. So I've given you some examples of AI in the maritime logistics that we are working on, ranging from just-in-time, estimated time of arrivals and departures, cargo tracking and monitoring, smart fairways, all the way to autonomous ships. So in case you are interested in learning more about this, please be in contact. The main point of all these is how do we reduce turnaround times from the seaside and land side, because that's the most cost-efficient way to reduce cost and emissions for all actors, usually above 20% for everybody. So great benefits for everybody. Thank you very much. I'm Kanno Tenavua, so here's my contact details. Thank you.
Yes, we just heard from 3 speakers, and now we are ready for the panel session. I would like to introduce the panelists. Please give them a big round of applause each time I introduce them to you. First, we have Professor Haerin Bae, who will be the moderator of this session. And next, we have Ms. Saran Turan from Hexagon. Taeyoung Kim from Robigos. Chang-woo Hong from the Research Institute of Dongyang Systems and Dongyang Universe. Sean Kim from the Artificial Intelligence Research Lab of ETRI. And last but not least, we have Mr. Carno Denovo from Awake AI.
Then I'd like to hand the floor over to the moderator. As I listened in the Smart Port World Forum, I could see that we addressed a different subject. The first session is about port automation. The second session is about intelligent port, how to make port intelligent. And the third session will focus more on the direction down the road for us to pursue. I think, well, the sessions are organized in a quite significant way and meaningful way. And in this session, I'd like to focus more on how to make port intelligent, and that is the subject we'd like to discuss at this panel session. And I'd like to thank our three speakers for their interesting and insightful presentations. And I think that will make our panel discussion all the more interesting and exciting. As for Ms. Churan, from the perspective of digital reality, she mentioned that there is various the geo information to make port intelligent. Well, thank you for introducing a very interesting case studies. And Mr. Kim from Rovigos introduced the concept of UAM, a new hardware technology, and which can be applied onto ports. And the last speaker, Mr. Gardner Darbu of Awake AI, briefed us on various AI technologies and its applications and to make ports intelligent. So I'd like to turn to our two panelists first for their comments and questions after listening to the three presentations. So Dr. Hong and Dr. Kim, I'd like to ask them to make a brief comment and ask questions. First, I'd like to turn to Dr. Hong of Gwangyang Systems and Gwangyang Universe for his comment or ideas. Good afternoon. I'm Hong Chang-woo of Gwangyang Systems. I'd like to thank the speakers for their insightful presentations. I think the presentations captured in such a strong trend. I have some questions. So before making comment, I'd like to ask some questions.
The digital reality that you mentioned during your presentation of Hexagon, you introduced technologies like digital twin. How do you define digital reality? Maybe you can talk about the definition of digital reality of Hexagon. And second, you talked about the single operational view. So on top of real videos, real images, you put in the monitoring function. So, from the perspective of an operator, rather than 3D, maybe they will actually prefer 2D. Sometimes 2D is easier. So for example, the navigation that we use for our driving cars. Rather than 3D, 2D is actually easier to understand quickly. So 2D maps are still used for this function. So how do you think about this, and what kind of strategy do you have? I am very curious to know.
Thank you so much. Yes, so for the first question, for digital twin or a digital reality, which I will refer interchangeably, we define it as basically having your organization or your processes exactly as it is in real life, as it is in software. So I focused more on maybe the visualization point of view to make sure that things are as is on the software world, but the same thing applies to how the processes work, or for example, if a person in an organization has certain rights to interact with data or perform certain operations, the same things can happen, and only those should happen in a software world as well. So we see this digital twin or reality as being able to have all these tools either through a map or through operations exactly how it is in a port, in this case, on a software that is very intuitive, easy to use, and can be applied to any port in the world. This is a bit brief explanation. I hope it answers your first question. And for the second one, actually, it's a very good point. I think we're so proud of our 3D visualization that sometimes we forget to mention. We do have, starting from 2D visualization to 5D, which sounds interesting to go with 5D, but basically for our maps, you have the option to convert or switch live between 2D and 3D maps, regardless of the environment you're in. So we have solutions for both desktop, mobile, and also web, but you can use 2D or 3D regardless of also the data sets that you have. So let's say you have these 3D models or point clouds. It doesn't matter that they're 3D data sets. You can put these also on 2D, or let's say you have floor plans of your organization or other 2D data, you can put these onto a map very easily as well. On top of this, when I say from 2 to 5, we go with obviously the XYZ components for the 2 and 3D, and then also for the 4D, we put in the time aspect of your data. So you have possibilities of for example, introducing a time slider that is available in our solutions to be able to understand your data through time. So what it was yesterday, and maybe with great collaboration with all these amazing AI technologies we heard today, we can make use of them to say what it can be tomorrow. So these can also be integrated. And then also for the 5th component, as it is usually for the data that we're dealing with, it's never just that the data has a visual component. Maybe you've seen in this video about the plant where it was clicked on certain components, and I saw in other videos from the other speakers as well, there's usually some properties associated to your data which actually makes your data more interesting and operable. So we see the 5th component as this metadata that is associated with the geometries or the GIS-based components to your data. So you also have this option to make filters or show certain types of your data, or show the data that is applicable to certain users. So it's a very wide range of dimensions that we offer. Thank you.
Then well, I'd like to turn to Dr. Kim for his questions. Very nice to meet you all. I'm working at a policy research institute. AI and the digital twin are the main areas of research. I listened to the previous session and this session, and I came to think that what making something intelligent means, what intelligence means. As I listened to in total 6 presentations, I think it leads to sustainability. There are various perspectives: economy, sustainability, optimization. These are the main themes when we talk about making something intelligent. But technology-wise, it is about prediction and recognition and detection in order to go for optimization. And IoT technology, AI technology, digital twin technology, and big data technology are used for that purpose. So I think intelligence seems to become some umbrella terminology for all that. But you know what? If you hand a mobile phone or a smartphone to a person, does make that person intelligent. So I think we are not covering human touch here. We should also talk about the human touch and the human involvement as well. So I'd like to ask the speakers whether they want to respond here. So making something intelligent in the process, the role of human beings and the positioning, change in the positioning of human beings. Is there anyone who wants to make a comment here?
Please.
So the levels of intelligence is related to the 4 stages that I showed in the presentation. First, it's about collaborative intelligence. So how to share the data and awareness that everybody has in an intelligent way. Then it's about optimizing the operations. So how you actually turn that data into analytics-assisted operations that I mentioned. And the third dimension is actually the level of automation. So there are many manual processes now that are being operated by emails and Excels, and we want to automate these processes, and eventually the automation level becomes such that some of these are operate without people in the loop, so the intelligence increases. So these are the three dimensions I see.
네, 답변 감사합니다.
Thank you for that answer. So now I would like to ask questions to each speaker. First, Ms. Saran Turan from Hexagon. So when we talk about intelligence, inevitably we end up talking about data. So the technologies today, whether it's AI or big data, it's all about data. The precondition of the technology is data. So when we try to build smart ports and increase the intelligence of ports to ensure safety and efficiency, we have to also leverage data. We talked about many different technologies today. So if we have high quality data, if we cannot secure high quality data, maybe it has no meaning what we're talking about today. So you talked about application of data today. And ports are very unique. When we collect data, there are a lot of metal equipment around the ports. Or I think same for smart city as well, but ports, everything moves all the time. Nothing stays the same. In this kind of environment, dynamic environment, how can we collect high quality data?
Yes, indeed. Actually, thank you for the question. This is something we get a lot from our customers, not just because the data is changing very frequently, but they also ask us, okay, the visualization is very nice, but I don't have data. Do you have any tools for us to acquire this kind of data? So maybe the first part that I want to answer is, of course, it is amazing to have very good quality data, and then you can exploit the software in a better way, but we don't have a requirement in terms of being able to use our solutions that the quality of the data has to be very high. So that's maybe one point to start with. And then the second one is, as I've mentioned before, I'm personally more focused on the visualization parts of Hexagon solutions. But Hexagon is a very large family. We do offer also some hardware, for example, Hexagon Geosystems. I'm pretty sure most of you are familiar with Leica scanners. So this is also a part of Hexagon family. So if you come to us asking, okay, we're very interested in having some point cloud data or meshes, we can very easily tell you to have some of these scanners. And this is very specific response, but the reason I wanted to also cover this is when you've mentioned that ports are very dynamic in terms of the changing infrastructure or the metal components associated. For example, one of the tools that Leica can offer is a scanner that is like this big, which you can very easily carry in your hand. So even, for example, things have changed in a few days, you can easily have someone walk around and then have the output of this available into your solution. And if you remember, I did mention that our way of working is never linear in our solution. It's always a cycle. So we want to have always most up-to-date data that is fed back into the system that comes as a result of some action. And then we always do some action based on the most up-to-date data. And maybe one last thing, I may be talking a bit too long, but I want to mention, so, okay, Leica here is a part of Hexagon family, but we're also very open to new either partners or other companies that we can work with to make sure we can have the most accurate data also on different fields. So for example, I did mention we have a few customer visits here in Korea. We also had one with a Korean company that is focused on indoor and outdoor tracking. So this is something that comes a lot also in smart port use cases where our customers or prospects ask us, okay, we want to use, but do you have some beacons or some technology that we can actually buy from you to integrate with your solution? So we're also investigating all these new options to have the most accurate data that we can suggest to our customers that we know works very well and then can be easily integrated to our solutions. Thank you.
Thank you very much. Now, I'd like to ask my second question to Mr. Kim of Rovigos. Port is a very sensitive place and facility because it plays a pivotal role in the national economy. And it is also related to the shipping industry, and it also needs to link the maritime shipping to inland logistics. You mentioned UAM and how to apply it to port. Well, some might wonder whether the technology is available for immediate application or not. As you mentioned, per terminal container handles 1,000 containers, 1 million containers. And as for Busan Port, it handles 20 million TEUs. But using UAM, I think UAM will serve as a connection point between the maritime shipping and inland logistics. Is the technology available right away? And if it is possible, in what areas of applications we can utilize the UAM? And around what time do you believe the technology will become widely available? Thank you very much for your question. The UAM industry itself is going through demonstration phase, and by 2035, we expect a booming of the industry. And exactly by when the technology will become widely available, I think somewhere between 2030 and 2035. And as you mentioned, one terminal handles 1 million containers, and in Busan Port, it handles 20 to 30 million TEUs per year. And how to utilize UAM, that is the question in my mind. And there are cases where you send products via vessel and via ship, and certain times where you send your items via air. And there might be some people who want to receive their container on time or earlier than scheduled. So there must be some cargo which deserve to be sent with a premium. If it is possible for you to receive your cargo, your item, in a matter of 1 hour by paying $100 more, then that's the point where UAM can serve better. UAM is to serve the short haul, and certain UAM aircraft can travel across the Pacific. So UAM can be applied for the maritime shipping industry, but between countries, transportation can be done via UAM. Thank you. In the second session, the speakers finished their presentation on time. That is why we have more than enough time for this panel discussion. If we do so, then as for the containers, you have to go through the customs clearance as well as the security check. But what about UAM? How do you think we can handle the security check and customs clearance? I studied this matter, but the concept of vertiport, this is like an airport for UAM. So before getting admitted into border port, the customs clearance should be done. So it's kind of a special delivery via UAM. The container can be scanned, and that kind of additional procedure can be introduced to facilitate this UAM express delivery process. And I believe UAM can serve as a facilitator, expediting the integration between the maritime shipping and the inland transportation. It can serve as a great linkage between the inland transportation and the maritime shipping. So I'd like to ask for your continued support. Thank you.
The next question is to the last speaker of today, Awake AI. There are companies that are performing similar functions like Awake AI in Korea, but there are usually government projects. We have what we call AIPC project. It means that predicting the ETI of vessels based on AI, also the arrival type of trucks, so that it can be used to better plan the operations of ports. And of course, this is based on AI. One of the challenges that we face in this process is, like Mr. Tenuvo mentioned, you need an ecosystem. You need a healthy ecosystem. So within this ecosystem of port operation, you can have the forwarders, the shippers, the truck drivers, and so on. They need to come into the ecosystem, but I find it very hard to persuade them to become a contributor to this ecosystem. Did you face any similar challenges? How do you persuade all of these industry members to come into the ecosystem? Do you have any advice?
Thank you. That is an excellent question. And I would say the challenge varies in different parts of the world. So for example, in Valencia and Livorno, to optimize the multimodal traffic, so how to link the shipping schedules, the truck and train schedules, you only need 3 types of information or data. You need the port call data that the port authorities do have, if they can just share that. Then you need the loading and discharging timestamps. This is something that the terminal operator has. And then lastly, you need the gate entry and exit timestamps. Usually the port authority has that. So if you can persuade the terminal operators to share this loading and unloading timestamps, so you don't even need to know exactly what type of data that is, then it's like game theory, everybody wins when everybody shares.
So thank you for that very insightful answer. I think we can apply that to our operations. I have one last question. I think it's something that everyone can think about, but before that, I would like to open up to the floor. So after we get a question from the floor, then I have a question from all of the speakers, and then we can wrap up the discussion. So if you have any questions participating offline, please raise your hand. I guess not. Then I can move on to the last question. So this question is, I think, also applicable to the last session of today, but we can take some time now to think about this all together. So the speaker mentioned about the definition of digital reality and intelligence, what it means to become intelligent. And if we have intelligent, does everything work out on itself? Is it a silver bullet? So the shipping environment and the port environment is changing very rapidly these days. And in Korea, there has been many efforts made to enhance the productivity of ports. I think that has led us to become a little bit neglecting the security and safety issues. And also fuel is a very big topic these days because we don't want to emit a lot of pollution. It's the same for ports. Ports want to enhance efficiency, but that may require higher fuel consumption, which is something that we are not trying to achieve. We are actually trying to reduce fuel consumption. So how do you enhance productivity while enhancing safety? I think intelligence can contribute to both of these topics. Intelligence can help increase efficiency. Intelligence can also help strengthen safety on ports. But my thoughts are still quite abstract. But I know there's a lot of research going on to both ends. So I would like to ask the panelists here, do you have any comments or thoughts on this?
Can I answer the safety part, please?
Yes, please.
So the last example I showed you was the digital twin we are developing with Port of Rotterdam and Antwerp. And we're using that same digital twin simulation capability to actually show an intelligent fairway. So no longer the fairway needs to be static, but they can also dynamically change according to environmental condition and congestion. So you can visualize or simulate these safety contours that reduces the amount of accidents or challenges that you have with congestion or weather impacts. So imagine this kind of system being in place in Suez Canal, for example, when Ever Given got stuck. We would have been able to simulate and predict the gust of winds and reduce the safety margins on the fairway, and maybe the accident would have not happened.
예, 답변 감사합니다.
Thank you. Then I'd like to turn to Dr. Hong for his comment. Whether it's safety or productivity, whether it's intelligent technology or other technologies, whenever we have a new technology, well, a bubble is created. And everyone talks about rosy future and all the promises, and over some time people would get disappointed. Then we become realistic and make some compromise. We talk about a place of human beings. So when I think, well, that we approach this as a pure technology, that is the problem here. As I talk to a general public, they believe that with the digital twin technology, we can do this and that. But to be exact, the goal is to implement digital twin technology which can perform those features and functions. So I think the order is reversed. Whether it's intelligence while becoming smart or safety and productivity, whenever we apply technology, we have to focus on the issues we want to tackle and the challenges we want to address, and how and what kind of technology we are going to apply. That should be our approach. We say all the time that we should first understand the demand and the requirement, and then we should move on to develop and apply technology. Then now I'd like to turn to Dr. Kim. Well, this is what I really wanted to talk about. Well, the efficiency of port is very important. RE100 and a disaster and the climate change, all those issues. When sometimes it's man-made disaster, sometimes it is natural disasters we are faced with, whether it's accident or disaster. Well, they are induced by human as well as by nature. But that's one of the aspects we have to consider. Another aspect is that we talk about data and AI, but we do not talk about the side effects of ICT technology, information and communications technology. Well, somebody mentioned security and the security threat. Digital twin, that's the same. I think, well, sometimes we make too much investment, excessive investment in creating digital twin, and maintenance itself would be quite difficult and too costly for us. And the kind of side effects we have to take into consideration in building digital twin. And the most important thing here is the integration and the linkage and synchronization between the operation and the system. There should be synchronization on a real-time basis, and there, in the seamless synchronization, we can find ways to prevent all the disasters to ensure safety. Thank you.
So the theme of the second session was ever developing intelligent ports. And I think ports all around the world are working to create smart ports. And some ports may have different approaches. I hope that smart ports will enable Korea to develop further. And I think today's session was very helpful in terms of providing insights. I would like to thank the three presenters today for their very valuable presentations. I would also like to thank the two panelists for joining us during the discussion, and for everyone here for tuning into this session. Thank you. Thank you. Ever Developing Intelligent Board. Session 2 of today's forum has just concluded. We will take a 15-minute break. We will come back at 4:25. The last session will begin at 4:25. The 2022 Smart Port World Forum will now begin its last session, moving toward full-fledged smart port. We do not have a panel discussion for the third session, but we have 4 presentations. The first presenter will be Professor Cheol-Eun Lee, and he will please give him a big round of applause.
Thank you. Thank you for staying with us till the end of this forum. And I'd like to thank YGPA for having me today. It's such a great honor for me. And I also want to thank the Ministry of Oceans and Fisheries. And I know the staff members of YGPA and staff members from Busan should travel all the way back to Busan and Gwangyang. And since we are running out of time, I will be on time. I plan to deliver my presentation in English, but I could see that we have a great number of Korean audience here. In the previous sessions, elaborated on the data analytics and AI, especially the panel discussion in the second session. Professor Bae Rim is well versed in this area, and Mr. Karnotabuo also went into details. So I will be very brief and to the point. I will skip most of the slide, and I will briefly introduce myself. Many of you are working in the port and logistics industries, and we have many researchers from the policy research centers. I'm not part of the government, and I have not many experiences in taking part in the national policy projects. And I worked at Singapore University, and I developed technology with the PSA of Singapore. And when I came back from Singapore to Korea, under the auspices of late Cho Yang-woo of Hanjin Shipping, I worked on the new port project. I developed a TOS in the new port. So rather than take part in the national policy project, I was the subject of the evaluation of the national project. I also had another session of evaluation by the Ministry of Oceans and Fisheries. But well, today I'd like to share with you my limited experience in this field. The need for artificial intelligence, the concept of and the definition of artificial intelligence. But I think, well, you don't need to listen to this anymore. Well, the concept of IoT and Levi's, they are now developing a fabric that can act as a sensor, as mentioned in the previous session. When I was studying abroad, my roommate was an Indian, and he became the head of a very famous U.S. research center. Then back then, my professor didn't like me or him. But anyway, he worked on the development of a sensor, and now we have such an advances in sensor technology, and now aircraft is equipped with thousands and thousands of sensors, and the terabyte, the data is collected in the unit of terabyte. So that data is analyzed in order to predict any malfunctioning or error in the system or breakdown. Airliners would have to suffer a great loss if there is any breakdown of the system. They would have to pay back, or they have to offer accommodation and so on. This has become possible, but you know what? This has been technology-driven. Technology-driven means that technology has been there. Technology has been around for such a long time. When I was in my doctorate course, I did some project in the agricultural department, and I'm working on a smart farm project and how to help grape farmers, giving them some weather forecast and how much water should be provided to have better crops. But you know what? My Indian roommate, well, he fully devoted his life to the development of sensors, and now we have such a sophisticated level of sensor technology. And when it comes to computing, we have a immensely higher computing power. Algorithm has been the same, but with this higher computing power, now we have a better predictability or predictive capability. AI boils down to prediction or more accurate prediction, and this has allowed autonomous driving. And as mentioned in the previous session, UAM. Well, when I was in Singapore, I worked only on ports, but since I came back to Korea, I started to work on drones and airports. Now we see the emergence of these new technologies. So this is a technology-driven innovation. Then how should we utilize this for ports? We have to consider whether we have actually used this technology for ports. As mentioned in the previous session, and as covered in the first session by the speaker from Hamburg, as for the German port or the European port, they are using IoT technology and they are making the most of data analytics in order to enhance not just productivity but also safety. My focus has been on productivity. I started to work with PSA because I mentioned AGB in my doctorate thesis. Well, double stack or moving backward or moving forward while using the AGB and using the applying a trolley approach and so on. But the final decision is not to introduce it because what we need is a collaborative technology which can collaborate with the human beings. Well, the Singaporean PSA port is really advanced. It is a transshipment port. In this case, well, you don't need any truck drivers union because anything can be done within the perimeter of the port. But Korea has both transshipment ports as well as export ports. So the technology and the AGB should be able to do some collaboration. The autonomous driving and autonomous self-driving cars should be able to work with human drivers. But the thing is that while self-driving cars would listen to you, while human drivers would not listen to you all the time. And collaboration is the key to enhancing technology. But in the past, the collaboration did not produce enough productivity in Singapore back then. That is why Singapore decided not to adopt it. But these days, they are starting to see some productivity gains. And as for the Busan Newport, other research projects were successful. But some technologies and some projects were not successful. It's not because the technology is too complicated. Well, somebody mentioned digital twin, and I was asked to implement digital twin, but we failed greatly. And in implementing AGB, we have to completely change the layout. The layout itself should be completely overhauled. So the route of cars moving within the moving on the quayside, and the route of the outside trucks should be aligned so that you can do the proper traffic control. But that was not fully realized at the end of the day, so we decided not to go ahead with that. But something which was not available in the past, it has become available these days. So 20 years ago, the introduction of AGB was formulated and considered, but it was not introduced at the end of the day. We piloted traffic control, the deadlock prevention, and so on. But we did not have sufficient productivity gains. That is why it was not introduced. But these days, Transport is introducing AGBs because that ensures enough and sufficient productivity gains. And my colleagues who worked with me back then are now teaching at Singapore National University, and they are leading the Tuas port, and they are leading this next generation port building and port creation project. And in Europe, as mentioned in the previous session, an IoT predicts traffic congestion and even helps reduce traffic congestions by assisting scheduling and thereby reducing carbon footprint and the congestion within the port side. And this is something I like to discuss in the presence of Professor Berry. So I believe everything should go in one package, whether it's AI, data, and productivity. In running a port, we should do the optimization of its entire operation. That means, we need everything here. So this is the prediction of the ETA. If you do the prediction, you can see the ETA changes over time. Then the berth planning cannot be maintained if the time changes constantly. Then you should do something to recover it in order to maintain and keep and maximize berth productivity. So data-based AI prediction can play a role here. And you should be able to predict and forecast the future efficiency. And through optimization method, you can maximize the berth productivity. So AI, at the end of the day, is this is the emulation result of my system. How much I could have improved the productivity at a certain berth. Especially by reducing the penalty due to some delay and congestion. You can see two different curves here. This shows us that AI is not doing something from scratch. Where AI imitates what berth planner does. So it can greatly imitate and replicate what berth planner does. And the same goes true for loading. Due to time constraints, I was not able to cover yard planning. And there is a yard planning and rehandling. The same goes true for these. As for rehandling, you should be able to estimate the time or predict the time of arrival of the shippers or trucks. If there is any error or inaccuracy in the ETA, you should be able to do the continuous adjustment for optimization. So that is a process of re-optimization over and over again. And this will lead to the maximum possible port productivity in the automated port, it is possible because you have under your side a fully automated facilities and equipment. Rehandling can be done at an ideal time, and through this rehandling, you can identify ways for the optimization and the maximum productivity. It's all about the prediction and reprediction based on data, and based on the reprediction, you can do the re-optimization over and over again. And this is how you can improve and enhance productivity to the limit. By doing so, AI and big data in combination can imitate and replicate what a great birth planner can do. So this shows how AI replicated the performance of a high-performing birth planner. This is not to replace a planner, but to assist a planner. The next part I will skip because that was already covered in the previous session. So data analytics based port congestion tackling and identification of the potential issues and the resolution of the issues. My previous presentation covers that part. Because that was extensively covered in the previous presenters, I will skip that part. Then what is the direction to be pursued by smart ports? Smart port will continue to evolve because we have technology ever evolving. Sensor technology is developing quite rapidly, and computing technology is advancing as well. So something which was not even dreamed of in the past is available right now. Data analytics and the prediction data collection will become available. And through this, port productivity and safety, as well as eco-friendliness and sustainability, will further improve. Port KPIs will increase dramatically. The key here is, as mentioned in the panel discussion, collaborative platform. Collaboration should take place not just within the perimeter of a port, but rehandling prediction based on carry-in, carry-out. Well, if that is to be done, then reservation system should be introduced. And through the collaboration or the incentive system with shippers, you can share in the benefits. And as for the storage planning, you can share data with shipping lines. Now you can work with carriers in order to improve accuracy in the storage planning and integrity of the storage planning. In that sense, collaborative platform is of greatest importance. And how to create a win-win situation and how to maximize the synergy is the subject of continuous research. And ICT technology is being developed to enable such a situation. And through this, we will see a whole new concept of port. TUAS port, the current implementation for the TUAS port utilizes existing technology, but you know what? It features a completely new concept, especially the stacking area operation. The approach is whole new. So they are introducing this next generation operation model, and this will lead to the development in shipbuilding technology, creating a situation where ships can go bigger. So the stability and the reliability of vessels, the solution to all the problems will become available for us. And Singapore is creating a whole new terminals at Tuas Port. So one of the terminals was relatively new, but they replaced that with the terminals at Tuas. And if YGPA wants to build a smart port, I think it can consider the option of building a whole new one, taking a whole new approach. This is the end of my presentation. Thank you. Thank you very much, Professor Lee. Thank you for sharing with us the actual case studies as well as the technological potential of AI and data analytics. I'd like to thank Professor Lee for his insightful presentation. Next, I'd like to turn to Ms. Gwangyang Lee of KMI.
Her theme is Korean Smart Port and Port City for Sustainable Growth. Please give the speaker a big round of applause. Good afternoon. I am from KMI and I'm currently belong to the Logistics and Maritime Industry Research Department. So my approach may be a little bit more broader. The world is changing and it's changing rapidly. So we need to look at the port and port city together. We also need to incorporate global supply chains. We need to include all of these factors or else we may face some challenges in the future. So that is the approach to my presentation today. So this is the table of contents, and as you see, the supply chain is, the first mile is about the commodities, and then the last mile is about sending the product to our final consumer. But in the middle, you have the middle mile. You have ports, you have transports, and you have platforms. All of this is dynamic and it are interconnected. So this middle mile sometimes is called the missing mile. So how to advance this will determine your speed from first mile to last mile. How do you approach this? And always the problems need to come from this middle mile. So improving middle mile can actually enhance your service quality. The global supply chain is very complex. You can see all of these interconnections, and on the right, it is about semiconductors. It starts in the US, it comes all the way to East Asia, China, and these global production sites need to manufacture the parts to make the final product. So if the global supply chain is disrupted, then products cannot be manufactured. And this is an interesting chart. We didn't go over all of the commodities, but we looked at the crop prices and the oil prices. And we tried to figure out which factor had biggest impact on global supply chain. And there is something called the GSCPI, Global Supply Chain Pressure Index. It looks at transport cost. It combines the air transport and the ocean transport cost, and it looks at the delay, and it looks at these factors to come up with this chart. You see in the middle there is the East Japan earthquake. At that time, semiconductor procurement was challenging. So you see the lines going up, and COVID made the charts jump. You see the Russia and Ukraine war pushing the chart upwards again. So if you look at this chart, you can actually figure out how the world is operating at the moment, at least in terms of logistics. It also look at the consumer prices. The red is the consumer price. It moves almost exactly the same as the pressure index. So watching this chart, you learn that stagflation is somewhat inevitable at the moment. So currently, cost of goods sold is increasing according to this chart, and we need to incorporate this backdrop when we think about our research. And because the global supply chain is so dynamic, I think people's thoughts on global supply chain is changing. In the past, it was always about the economics. So cheaper manufacturing was driving global supply chains. But now, reliability is becoming important. There is what we call friendshoring these days. What happens if relationship with China deteriorates? Maybe India can be an alternative. And overall, ports are connected to each box you see here. And this is an index that I monitor frequently. Gartner announces the top 8 supply chain technology trends every year. In the past, there was not a lot of change. But since COVID, 2020, 2021, 2022, we talked about ecosystems in earlier sessions today. So ecosystem and collaboration is becoming important. And autonomous driving and autonomous vessels, autonomous technology is becoming more prevalent. And digital technology is becoming more important as well. And against this backdrop, global leaders said that they thought the global supply chain and digital global connection was intact, was very strong. But now they are figuring out that there are some loopholes into the global chains. And in that regard, against that trend, the technology is developing and showing dynamics that maybe we did not see in the before. In July every year, Gartner announces the technologies that are newly emerging and the technologies that are also disappearing. And they mentioned the AI. And now generative AI is not enough. We need diagnostic AI nowadays, and we need technology that allows us to collaborate on cloud. So we need more advanced technology now. So you can see as emerging technology, cloud data ecosystem on the right chart. So in the pandemic, or maybe because of the pandemic, the world has changed. And immersive experience is one of the new technologies and concepts that have become more popular since the pandemic, as well as metaverse. And they heavily use image. And they collect location information, and they use modeling technology. I recommend that you watch Ready Player One because it really shows how metaverse and immersive experience can be rendered in the future. So technology is evolving. Where are we? Where is Korea standing at the moment? The government is making tremendous efforts to advance technology, to digitalize, to automate. I think now we are trying to broaden the concept of smart. I will go into detail later on, but we need to broaden the picture now. So if you look at other global cities, they are connecting supply chains with port with port cities. So they are broadening the concept. And port. It seems that the infrastructure is stagnant, but actually it is not. It is actually a living organism. And ports and port cities change continuously. So at first it looks like the space is expanding, but the logistics function as it grows, then they connect with each other. So port and logistics and hinterland are all connected. And when that relationship becomes robust, the port's operation becomes strong. So ports is a living thing, living organism. It continuously evolves, and we must remember that it is dynamic. And looking at the case of Rotterdam, how can we offset CO2 emission? How can we renew the port? How can we optimize the cost? They thought about all of these questions, but I think they also thought about the autonomous vessels. If an autonomous vessel comes in, how do we respond to that? So in that sense, they try to make their ports smarter. And I think they didn't really start. They started by trying to answer simple questions, and those incremental improvements led to effective and big changes. And I think if we look at the case of Hamburg, they are taking a more overall approach. They are trying to deliver a fully connected smart port as well as achieving zero emissions. They have 8 dimensions of their framework. And one of them is that they will become a digital leader. And if you look into this item, this was announced several years ago, but they still talk about traffic control, how they are going to leverage AI to port operations, how they are going to equip their employees with digital skills. And maybe these 8 items are important reference points for other ports if the port is trying to become a smart port. The economic growth rate annually announced by IMF is only around 3.2%. But against that, the smart port market is growing very rapidly. There is some changes that we see from several years ago. Several years ago, it was expected that Europe will grow quickly, but actually Asia takes up around 50% of the market, and market change is driven by Asia, and technology is shifting from process optimization to automation, so digital twins. And automation is strengthening. China, Singapore, and Korea, in that order, these markets will drive the Asian market. And from now on, I need to make sure we define the concept. So step 1 of smart port is about unit optimization. Optimization is combined with intelligence, so they are becoming smarter incrementally and more data is being collected. And then it expands horizontally. It focuses not just on the port, but it also includes the port city and so on. And then stage 3 is digitalization. If you look at the layers on the bottom mentioned by McKinsey, you can see layer 3, layer 4, and layer 5, what drives digital ports. And this is the unit optimization, the first step. We look at the K crane and the vessels. They have all worked to optimize their operations. But this is not real-time data. It looks at the gate data and the implementation data. There is a gap. And the control method, controlled by people. So maybe there is something wrong, but if you look at each unit, everyone was doing a great job. But maybe overall there were some problems. Then step 2 is automation. You're automating just the port. You change the yard cranes, or you look at different adjustments and incremental changes. The sensor is on the automated equipment, so we get real data. Real-time data, but that is not the case for everything in the port. So there is still equipment in the port that does not have sensors, and real-time data cannot be collected from those equipment. And then step 3 is digitalization. Everything, including people. So we talked about digital twin earlier, and they talked about adding sensors to everything to collect real-time data and to process that data. But you cannot think of all of the variables at the very beginning stage, because when you start the simulation, then you will face so many errors. So step by step, you need to digitalize and collect more data from more equipment. And then step 4 is smart ports. You look at the data of the port and also the port city. All the environmental data are collected, and all that data is linked to enhance the productivity. But the emphasis here is that we're not just looking at the port, we're looking at the port city as well, like like the case of Hamburg. And after introducing the smart concept, then what can change? You looked at the Suez Canal, and all of you know about the Ever Given case. So when this became stuck, about 185 ships stood still around this area. So 30% of the maritime transport happens around the Suez Canal, but all of that was suspended. And we went to the Suez Canal during this time, and I think technology may have prevented this from happening. So the smart ports can become more effective in preventive activities and also addressing the aftermath of accidents. And we have the truck waiting simulation. In the past, port simulation and truck simulation was conducted separately. But truck are assigned dates. They are not assigned times. So you see the red. Everything is rehandled, so they need to change. But if we could assign them time and have the truck drivers come in order, things could have been done more effectively. So I think if we have more real data, we can make more accurate predictions for the truck drivers. And then step 5 is digital transformation. I talked about the port, the city, the supply chain, and then we have the KPI. KPI is the goal for the ports. After defining the goals, then the port and the city can all come together to continuously provide feedback and think together on how to create more value. In other words, digitalization does not mean more sensors. It means all organizations of the society understands that we are all headed toward a same goal. And because sensor technology is continuously evolving, I think this digital transformation step is ever more closer than before. So when we talk about the concept of smart port and port city, they talk about the efficiency, they talk about high quality of living, and unlike the past when everything was conducted in silos, we need to bring all of them together. So connectivity becomes important. How to connect, and this connectivity will be essential to delivering a true sense of a smart port. And we looked at whether Korea is doing a good job. We looked at 5 major ports, Gwangyang and Pyeongtaek. We can't get the individual ones. We get the information of each city. If we look at the port industry, it's above 1. It means that it is very developed and advanced. So Busan and Incheon, it's very advanced in that sense. If you look at the right, we input the data properties, both digital twin and data collection. So Busan is still above 1. So it means that they are making effort to leverage data. The other ports are below 1. So there is some more effort to be made. We looked at some other ports. The data element does not really impact this score, especially if you look at Rotterdam, Hamburg, Antwerp, Barcelona. Even if you input the data properties, they still have similar scores. So it means that port and data have already been developing together. If you look at future ports, you have hyperloops, and in the middle, so people are analyzing data, and we have drones. All of that is combined to create a new world. And if you are placing an order, so the container units are slightly different, but we can make that into cube units. And 3D printers can manufacture parts and be used to higher the efficiency of maintenance. And you need to incubate the smart workforce. You need people who can run the simulations and you need people to be equipped with digital skills. For smart ports to become more advanced, you need the city's support. I keep emphasizing the city. If you look at automobiles, they have the actual car assembly manufacturers, but you have all the part manufacturers around it. So this type of total approach is very important. One of the challenges that I face in my research is that sometimes it's really hard to find the solution. The most recent research, why is shine musket not transported through the ocean ships? And second, what we checked that one container was not manufactured, so it could not be transported through the ocean. And so we tried to build the container and send it on one of the ships to the US. So I think maybe instead of trying to be too big and too abstract from the first stage, if we can focus on the details, we can make incremental changes to have more advanced sports. Thank you.
Thank you, Ms. Lee, for your informative presentation. She elaborated on the need for smart port as well as the port cities. Next, I'd like to turn to the presentation titled The Age of Digital Transformation, New Trend of Digital Twin Technology. This will be presented by Mr. Tae Kim, the CEO of Samu Immersion. Please welcome him with a big hand. Very nice to meet you all. I'm from Busan. I know you must be quite tired because you have been here all day. I came from Busan only this morning. I'm a business person and I'm working in this field. So rather than presenting some academic theories or definitions, I'd like to share with you what we have done so far. But the title is very big. But my presentation will focus on various digital technologies, XR, VR, and AR, as well as metaverse. I'm currently based in Busan. When I was little, but after I graduated from university, I was on board and I traveled the world and I worked on a ship for a long time. And that means I have a logistics industry background and I'm also working in this IT industry, so combination of various backgrounds. So this is our promotion hall of my company. So we create a metaverse. You know, metaverse has become extremely popular because information can be presented not in a two-dimensional form, but in three-dimensional format. People these days, the younger generation, want to see something intuitive. They want to encounter the information in a three-dimensional space. That is why, in that sense, metaverse is very effective in connecting people. And in presenting information, this is very efficient and effective. There are various attempts to apply this into industries. This is not a silver bullet. This is not the magic solution to all the problems, but there are key features we should make the most of. If we can match that key features to the problems and the challenges at hand, I think we can be successful, and that's the focus of my company. These are the areas of businesses we are involved in. Let me go through one by one. We are using extended reality XR in creating immersive job training content. In various areas of industries, we are developing and offering content in order to enhance job capabilities. The reason why we are using this approach is with the digital transformation we have seen many attempts. And the one thing people are overlooking is whether it's AI or robotics, they cannot be the solution in and of itself. The key lies with the people. Well, there would not be any area where something is completely unmanned. So those technologies should be used to enhance productivity and efficiency. But with the ever-changing solution and technology, people find it quite difficult to adjust themselves and adapt to these changing environment. And how to help those people? People are faced with a completely new working environment, and how to help them adapt to a new working environment. XR can be one of the solutions. And this is another solution titled the Smart Worker. And this is a remote worker support system. There are some people who might be slow in working, and those who can do better can assist a person to do a better job. Of course, AI might go through another round of development and advances and be able to help human workers, but we will have to wait for a long time. So rather than integrating AI right away, we want to create an infrastructure where we can improve the efficiency of human workers. There are various technologies which can do that already available. The thing is that we are not applying them in the right way. But I think, well, this is possible. Then in using these technologies, we cannot use existing solutions as is. That is why we have to renovate and reform those technologies, and some of the technologies need to be augmented and supplemented. And in order to do that, we have to know what we want to do and which area we have some shortcomings. We need some insight in order to improve and make improvements on the existing technology. Rather than blindly applying existing advanced technologies, there are many cases where my customers feel frustrated because they do not have enough understanding as to their needs. We are developing training-related content, and we have defined areas to be addressed down the road. There are various areas. We need some AI-related technology, and we also need GIS technology. So when I talk about digital twin, I will elaborate on this later. For a long time, I have worked hard to incorporate this XR and these digital technologies into industrial site. But many people did not have any understanding as to that. Well, many people say that it's inconvenient if I feel dizzy when I put on glasses. But what I was looking at and looking forward is the effect of the technology in the background. You know what? The VR technology was developed back in the 1960s. The technology was developed not for the purpose of experiencing something, not for having fun, but actually that was developed for the training of pilots. But these days, well, the VR glasses and VR goggles are used for experience, not for training. But we have to understand the starting point of this VR technology. And let me turn to AR technology, augmented reality. You believe that augmented reality is to place yourself in a cartoon or something. Well, this is not about Pokemon games. The key is to experience and information in an integrated manner. In that sense, we need AR technology. Well, so people that are quite hesitant to this idea of using goggles, there are areas where you don't have to look at information in an integrated manner, but in certain areas you have to continuously match the real world information and the virtual world information. But if you can use goggles, and if that information is presented intuitively, then it can be really effective. So those areas where technology can be taken advantage of should be clearly identified rather than believing that technology will solve all the problems out there. So I believe we can make the most of this kind of technology in enhancing productivity in industries. As for job training, we have set up our own HR development center within the company. The reason why we created this center, although my company is rather small in size, because when I recommended the use of VR goggles to my customers, because they are not really familiar with the use of VR goggles, they just play some video, but there is a clear goal that we want to achieve by using goggles. If it's a high risk and high return, then you should use VR goggles and the VR technology. And if the work process involves high risks and danger, then in that case, you have to use VR. So that is the reason why I set up this SWXR campus, XR-based educational facility. And using these content, you can be trained in the real-like environment. And you can go through the entire work process, not just the environment. So this is a digital twin of a LNG vessel, and the work process is all embedded here. LNG vessels are being manufactured, but there is no vessel available for us to be on board. Other than the LNG carriers, and LNG powered vessels are not really available. But from next year onward, LNG vessels should become available, and that will come into the market in a large volume. So you should be able to train your crew. So I think, if we make the most of XR and the VR technology, then we can ensure a certain level of exposure to this new environment and working environment. But the focus has been on the three-dimensional visualization, but I don't believe that's the key part. What kind of solutions we will incorporate, I believe that is quite important. So this is the medical application as well as the aircraft application. Then let me turn to XR-based digital twin solution named Valos. My company developed. We have developed a digital twin solution for industry, and this journey has started quite a long time ago. This is AR technology, and I believe this is a digital twin too. At the port, we can collect and put together the real-time information on a real-time basis, and this is a matching into the three-dimensional space. But there are vessels which do not have information. But as you can see on the right bottom, we can utilize artificial intelligence technology for vessel recognition. And based on these different types of technologies, we can do the monitoring. Why are you doing this? This is for a swift decision making, for a manager to make a quick decision, an accurate decision. That's the goal and the purpose of digital twin, not to have some fancy system that is to assist a swift decision making. This is related to safety as well as productivity. So we have this anti-collision feature. The possibility of, or the risk of a collision can be presented visually in order to avoid any collision. And this is a digital twin of a Shinseondae terminal in the Busan North Port. and the visualization was done by my company. And we mimicked the Shinseondae terminal. We went one step further. We had human workers, cars, and trucks. It's exactly the same. Well, this is an exact mirror of the real world. Let's take a look at this video. In creating a digital twin, we use game engine. Unreal engine was used for creating this digital twin. The focus is not on creating a great 3D image. The point is to have all the items identifiable and detectable. So if one item moves and if there is any change in the status, the information is updated on a real-time basis. And the virtual world perfectly reflects the real world. That means that from the perspective of a manager, by looking at this digital twin world, you can make a decision related to the real world. And how we did the synchronization as for cars, but we load and incorporate the IoT devices. And we get the GPS information of all those cars. And as for human workers, but if you install an application in your smartphones, then your characters will walk along the path. The role is to see whether the person enters any dangerous area, if there is any risk of collision with a car. That's the benefit and the beauty of this technology. And data-related standardization was mentioned previously. And one thing I'd like to highlight here is that as we implement this, the GIS or location-based coordinates, as for port XY axis information or coordinates is used in certain cases, not WIS. In certain cases, while GPS information is used, in certain cases, the XY axis coordinates are used. So for a smooth integration, this needs to be fixed. If we can use WGS for any occasion, then we can easily identify and detect objects. This will facilitate the integration process. So that means that there is a great volume of data to be standardized. So we need a certain time and process. Well, many people believe that digitalization costs you a lot. But that is not the case because we have container boxes and we have cranes. So in building a new port, well, you can use existing cranes and containers. The same goes true for digital twin and digital twin system. Digital twin is not a far-off dream. And this is quite accessible for anyone in a port. Well, this is a technology available at hand, but this is not a silver bullet. What we are going to do with the digital twin, what we are going to do by monitoring this. And one of the ideas I formulate here is that in this three-dimensional world, we can accumulate information. We can put together information, or, for example, the data of movement, and if there is any delay pressurizing the productivity, we can visualize it. That's the beauty of this technology. Last but not the least, Busan is known for Jagalti fish market, this wet market, and we put together all the digital twin in the 5G technology. And this will be the last piece of my presentation. So as we create a digital twin for Jagalti market, all the components have become visualized. Even the pipelines and one small light was visualized. Rather than just providing a visualization, we showed and we reflected the status. If the light is on, then the light is on in the digital twin. And on one side, you can control the temperature as well as the lighting by installing sensors, but you can turn on the ventilation for the entire building, and or air circulation system can be turned on. And this incorporates AI. 자갈치 market provides water from the sea. And we do not know why, but certain cases, but the muddy water is supplied. So we installed sensors to measure the external environment as well as the quality of the seawater. Then we conducted an analysis based on this. We could do some prediction if there is any, the signals of muddy water coming in, then we stop the supply. So rather than just doing the visualization, we collected the data and utilized them for the better prediction so that we can create a better environment for the users and for a cleaner environment for the users. So this is how we apply the technology. So let me conclude my presentation. Various technologies are available out there. Many people believe that digital technology can be a silver bullet, but I believe that's just one of the tools out there. The key here is how to tackle what kind of problems you want to tackle using digital twin. Whether it's AI or other digital technologies, should be utilized for that purpose. This is the end of my presentation. Thank you.
Thank you for that presentation, Mr. Kim. And we heard about the digital transformation era, new trends in digital twin technology. The last speaker will join us online. We have Ms. Jane Hyder, the professor of Cardiff University in the UK. He will talk about the port-oriented ICT system.
Hi.
Yes, if you're ready, you can share your screen and go ahead with your presentation.
Thank you. Hi, everyone. I suppose I have to say good afternoon, everyone in South Korea. To introduce myself, my name is Jane Hyder. I'm a senior lecturer in Cardiff University, Cardiff Business School. And I'm also the program director for the master's degree in maritime policy and shipping management. And today I'll be joined by Dr. Tiao Yip. So Dr. Tiao Yip is from the Hong Kong Polytechnic University, and he is currently the Associate Dean for Students, and he works in the Department of Logistics and Maritime Studies. So it's our great pleasure to join you today in your forum. And over the years, we had very close ties with South Korea, and in the past year, we worked with Chang Wook and Hung Yan. I wonder if they are there because I can't quite see everyone. So I had a great pleasure to learn about Gwangyang Port, and we worked on dissertations about Gwangyang Port too. So it's a great pleasure for me to talk about this research in today's forum. So without further ado, what I want to talk today is about the concept of port-centric ICT systems. So I will cover the first bit, which is about key features of what port-centric ICT is and what port-centric system is, and then Dr. T.L. Yip will follow me and take over to talk about a few examples of port ICT systems. And today's talk is based on two publications. The first one, it's based on a book that we've written together, the book chapter. If you're interested, by all means, please have a read. The book chapter is about port-centric ICT system, building value in supply chains. And a more recent work is Harvard journal paper. So the journal paper is an empirical study. We explored port-centric ICT system based on a survey in Qingdao port. And Qingdao is a port in China, sort of in the west coast of China. So that's an empirical study with a case of Qingdao. So by all means, I've listed these publications here. I'm sure the organizer will be able to share these presentations with you. So if you are interested, please have a read of these publications. So as we know that port is an important node in the modern supply chains. It plays such an important role that it interacts with so many different partners in the supply chains. So take a look at this port logistics and its linkage. So you can see that port authority links with terminals, depots, shipping agents, barge, and they further feed into shipping lines, customs, forwarders, and eventually it connects to rail and road. Yeah. So this is a picture that shows kind of a decentralized how they interact with each other in a dyadic manner, so one-to-one, not a centralized manner. So this way information is shared inefficiently, it's not shared in a centralized platform. A traditional information and communication technology system works if we look at the supply chain from a shipper to a consignee through terminal operators, carriers, and then another terminal operator. You can see that if they communicate with carrier ICT, terminal ICT, logistics, and shippers ICT, there are many different platforms for them to share the information. And this is not the most efficient way to share because other parties are not aware of the information, and many times information are shared multiple times. So the concept we're proposing here is a port-centric ICT system. Is over the years, seaport really kind of evolved from a simple transshipment point into a key node in global supply chain. Really, there is an increasing need for port to really play the role and fulfill different supply chain partners' needs and provide a value-adding service to its partners. So that's the whole concept of a port-centric logistics. So this figure shows you a centralized port kind of function. So a port-centric ICT, it serves the onshore transport, it serves the water transport, and further on the road transport in terms of warehousing and distribution. So port-centric ICT really helps a port to function as a critical node in the supply chain and bring value-adding services to its partners and fulfill various partners' different requirements. So this way, it's a centralized hierarchical platform for port-centric, for a port to share its information with various supply chain partners. So how can a port serve as a center role? Really, we say the digital technologies are really the key information here for a port to share. So the digital technologies, they are dramatically reshaping the maritime industry. I mean, you are all the expert. You can tell me about what a big role ICT or digital technologies are playing in this day. Talking about blockchain and the various Internet of Things and various different platforms that port uses. So here we're really proposing that it's absolutely critical for the ICT or digital technologies for a port to serve as the central role in global supply chains. So this is a change from the previous decentralized platform to a centralized platform, the port's ICT system. So it's a centralized platform, and it streamlines all the different players, including carrier, including terminal, including logistics and shippers. So information is shared through a centralized way, which makes it much more efficient. It makes much more sense for all the players in the supply chain. So now this slide shows you kind of what a complicated system a port plays in global supply chain, what kind of multiple functions it has to serve. So from a supplier to a customer, it involves buy, ship, and then pay, and so many different procedures, from commercial procedures, transport procedures, regulatory procedures, and financial procedures. And all these different functions involves various documents, various information to be shared, from prepare for export, transport, and then prepare for import, and then eventually import. So this is a chain that involves complicated documentation, complicated information to be shared with various players in the supply chain. So what we are proposing here is ICT system really helps. It's the only way a port can rely to become a smart port. Okay, so it is dedicated for international trade logistics, initiated by government agencies, and it covers all the financial settlements. So an illustration here to show you the international level supply chain from a buyer to a seller through the port community system, and eventually once the cargo is imported through a domestic level supply chain reaches the other end buyer through e-markets, B2B e-hub, e-logistics systems, etc. So really the key advantages of a port-centric ICT system is it ensures that all modifications to a file are made in one place in a centralized way, and it also makes it possible to process large and bulky files only once. So this brings me to a few examples we want to cover here. The first one, I might just make an introduction and then I will pass it on to Dr. T.L. Ip. So this is a study that we did exploring the impact of port-centric information integration and port performance in the case of Qingdao Port. And we did an empirical study using questionnaires and surveys to really look at how a port-centric information system serves its partners. So here, to list kind of the complexity of it, we have terminal operators, barge operators, road partners, product safety authorities, forwarders, shipping companies and shipbrokers, rail operators, port authorities, importers, exporters, agents, etc. So we're proposing here is there is an internal information integration, and there is also an external information integration. So we were intrigued to know that what's this information integration, what's their impacts on port performance, because ultimately port performance, it's really how we measure whether whether the ICT really takes has an impact or not. So we were intrigued to look at the impact of a port-centric information system, the role it plays on port performance. So here is a conceptual model. I would very much like to pass this on to Dr. T.L. Yip to give you a few examples of how port-centric information system works.
Yeah, thank you, Jane. Okay, maybe I follow using Jane's screen. Okay, so here you will see we would like to tell the reason, okay, why we want about, say, today we talk about smart ports and other advancement, okay. The key message here is that we want to know why we need a smart port or other setting. The reason is that in this research, okay, we try to tell, okay, if we could enhance the port, smart port or other, like a port center system, okay, we could, okay, increase the port performance, okay, very much. So that's why we did this analysis or research. And from here, we have several hypotheses here. The first one is that we say the internal integrations, if you have some information integration internally, it will enhance your external information integration, okay. Internal, I think is most people know, okay. This means that within your company, with others, say the departments. But external is that we would like to include port and other, like other members, okay. And behind that, okay, we need to develop something like a port communication system, okay. So in this system, we will try to remove, okay, most boundary between different parties, yeah. So this is the central core. And finally, and all these things we expect, okay, they will contribute to the port performance, okay, like the financial return, the overall efficiency, yeah. So this is the motivation behind this research, okay. So we developed that into different hypotheses, okay. Then we did the analysis, okay, behind this concept model, yeah. Next piece, okay, yeah. So here is if you see, okay, there's a lot of integration within the internal parties and also the external parties. And apart from that, okay, you will see, like Jay, okay, mentioned earlier, there's some competition between different systems. Someone say, because if you know, okay, we have a data today, okay, you are the king. Because there's a lot of information and also value generated by data. Yeah, so data is very important. But these are some competitions. Someone will say port should be the center. Someone will say the shipping line should be the center. Someone will say the government should be the center, okay. From our analysis, okay, we can confirm that port, okay, seaport is the very good one, okay, to be the center port, okay. So that's why today we talk about smart port very much, okay. Instead we talk about smart shipping line, or we talk about other, okay, center system, okay. So port is really the key person, okay, the key parties in this system, okay. And then based on that, we did the analysis, and then the results follow, yeah. And sorry, next piece, okay. And the result we found that, okay, in general, okay, internal analysis may not be able to enhance the port performance overall, but very key message we find here, the port, we see the middle circle, okay, the port center operation system, okay, could enhance the port performance, okay. Talking about, say, here we find that it's a 0.572. So you can expect, if you do some enhancement for that, this is the major contribution to the port performance. Yeah, so this is very important. So apart from other system, okay, the port center system is to have a very quick contributions. And then the external part, like external integrations, will contribute the port performance. Relatively also quite important, but just as 0.314, okay. And then one message very clear we can see here is that if we can enhance the internal system, it will enhance the external system at the end, okay, per performance very well, yeah. So that's a very good reason, okay, why people, today we talk about the port integration, smart port, all the things, okay. because it will enhance or contribute to your internal systems. And if we could make your internal system well, okay, it will at the end contribute to the performance at the end. Yeah, so this is a very important message, and the research confirmed that this part of contributions. Yeah, and also if we could make your internal system well, okay, then it will help the external integrations. Yeah, so that's very good. Okay, we can start from internal system and then gradually we make it to the overall contributions, yeah, to your performance. Yeah, so this is a very promising message here. Yeah, and then the next is we will see this in the market. Now we have a lot of competitions, and today we see a lot of good application and also advancement from Korea. Yeah, but we will say some other locations will develop their system, and they usually, you see from the name here, you see most of them start with something like a port-based system. Okay, like a port-based, start from the Rotterdam port. Destin 8 also start from a port in UK. Another one, most of them is integrate the port system. Someone a bit special, like a German case, Daco Sins from Hamburg. Okay, that one is starting with the Hamburg port plus some financial institute. Yeah, so this is a direct integration between the port system and also the financial system in Germany. Yeah, so all here you will see, okay, a lot of location and countries, okay, they are trying to compete in this market, and the port-based system compared to other central system is more promising. Yeah, so that's why you see here some other system, I guess you know, okay, like a shipping line based system. Also, there's a quite strong, okay, like a MERS, okay, developing their system. Another like a Hong Kong, the Costco also developing their system. But somehow we will say for the local economy or for port performance, the port center system is better, yeah, compared to other shipping line or other government-based system. Yeah, thank you very much. Maybe we can see the next slide. Then this is an example from the Destin 8. Okay, so you will see, we say earlier, this one's a UK-based system. Yeah, because of Jane is a very, they are in a UK university, so that's why we look into this system quite closely. Okay, especially you will see this one is based on two level system. One is based on the Destin 8 itself. It will link to different cloud server system, and then they will link it to the web server, yeah, a virtual server and other things, and then we'll link it to different customers, yeah. So this is quite typical setting today, and then there's somewhere the system and the cloud system will have a good protections. So another one is like a portrait. That one is based on Spain. Yeah, Spain also quite active in this area, and this one is try to link the system relatively, okay, try to minimum or reduce the connection between different parties, and then there's their port tech system also working quite well. Yeah, and the idea is similar to the one we said before. Yeah. And the next is we try to compare different features here. The port-based system and the Destin 8 system, one is based on the Rotterdam, and that one try to integrate a different function in the port, like export, import, and consultations, and try to help some decision-making system as well. And the Destin 8 based on UK, that one also will enhance the export, import, transshipment system, and that one also web-based. Other system you will see like Denmark one, okay, they will try to extend it to the global supply chain system, and other one like Dotsin or Portugal, okay, we see like they will try to connect with different hinterlands. So all these systems are competing, okay, yeah. So let's see, we will see there's a lot of features there, and the features example why we say the port center system will enhance the performance. Yeah, example here is you will see if it's talking about the letter credits, then we will reduce from 3 days to 0.3 days. Another one like export, import, export documents also will reduce from 1 day to 0.3 days. This statistic, okay, was World Survey in 2010. Now you can expect the speed is much faster. Although the manual work is still quite slow. Okay, somehow, yeah. Then yeah, maybe we can jump to the maybe we can skip this part. Okay, because this is physical work. Maybe we can skip a little bit because we still use a lot of time today. Maybe we jump to the next talk about the conclusive, the information trend. Okay, Alex, please. Yeah. Yeah, this one. Yeah, thank you, Jane. So the trend here is we would say port, okay, especially the container terminal become very informative, intensive, and we will say there's a lot of competition between different information owner, and we would say port or container terminal is the best locations to collect the information and also to make the good use of information. And at the end, we will enhance the performance. Yeah. And the port center system is quite well, okay, for the information sharing and also can work with the government, local government. So we will follow a different jurisdiction and also the legal regulations. So this will be ideal positions. And the port now you can see is more than a physical hub, and it is this information hub. And also we expect, okay, with the new generation, especially today in Korea, you all discussed that they will become the information network for future. Yeah, thank you very much. Yeah. So if you need further information, yeah, you can see our publication, and also this is the first idea we published in 2016. Yeah, thank you very much.
Thank you so much, Theo. That's all. I hope you find that useful. And as I've said, it's our great honor to be invited to speak at your forum. And by all means, get in touch if you're interested in our research. And we very much look forward to future visits and future collaborations with your port, if possible. So by all means, get in touch. And last but not least, Merry Christmas, because yeah, it's 2 weeks before it's Christmas. So I wish you all the best, and I wish you all a peaceful time over Christmas. Take care, everyone. Thank you.
Yes, thank you very much. I think that was indeed a great way to wrap up our forum today. 네, 전문가 여러분들을 모시고
So we explore ways to tour the smart port. I hope that today's forum makes any contribution to Korea's development into a smart port leader in the world. I'd like to thank all of you for staying with us till the end of today's forum. Thank you.